Hello world! This is CS50 on Twitch. My name is Colton Ogden, and happy 2019, happy new year to everybody. Whether you're new or a regular from last year, welcome to our Twitch channel where we do sort of live coding demos, tutorials, explanations, and all kinds of stuff. We might even get into some hardware-related stuff if some of the staff, is privy to that sort of thing. We've got a bunch of people in the chat. I'm going to say hello, as usual, to everybody who's here with us already. And let me know if I sound OK. We just completely reset up our stream setup. We took all the stuff that we had set up in this room, on our streaming room, last year in December. We took it all, basically used it for the fair, brought it back, and then reset a lot of it up today. So hopefully everything looks and sounds like it did last year, if not better. But definitely let me know if not. I'm going to go through the chat here really fast just to see who joined us here to begin with. Looks like M. Kloppenberg, a regular from last year, when I was doing a little test message. Says test received. Bavik Knight, another regular. Hey, everyone. Hi, how is everybody? Happy 2019 to everyone. Happy 2019 to you as well. Suratan, who just followed, actually. Thank you very much for the follow. Hello, CS50 family with the popcorn emoji. They say, Body A2610, sup. Nice. Oh, I can't read that name at all. The Genghis. Oh, that's the Genghis Goat 19. Also, thank you for the follow. I see Genghis Goat 19 just followed as well. Thanks to everybody who followed over the break. It looks like there were about 200 people that followed while we were not streaming over the winter break. So I was in California. I was far away from Boston over the winter for the last 3 or 4 weeks or so, visiting family. Back in Boston, and it's very cold today. It was fairly nice temperature for the last week or so, and now it's like 20 degrees today. It's freezing. Kiryu with the 2 clown faces, thank you. Suratan's got smiley faces. Tuxman29s, int new year, last year, return last year plus equals 1. And that's Tuxman29, a little code snippet for everybody to increment the year. And then Suratan is another thing, it's basically saying if last year is null, age is 1, right? Because if we weren't any age last year, null's not a valid age, so we need to be at least 1, right? Bella Kira's happy 2019. For Sunlight, hello. Colton, the regulars and all, thank you very much. Let me see, make sure I'm not missing anybody. Didn't do the assignments yet, but watched most of it and worked with Django. Oh, that's for the talking about Brian's web dev class. Yes, Brian actually may be in the chat today. He and I chatted before the stream started. Suratan, Ofex, hi Johnny Bravo. This is Ofex, surely a reference to my hair. It is a little Johnny Bravo looking. I need to get a haircut like super badly. I haven't gotten it cut for like a month. It's pretty insane. Man, some of these names are hard to read because Twitch puts them in like this really obnoxious blue font on black. M. Gunami. Hi Colton, I hope I'm pronouncing that right. I'm probably not pronouncing that right. Sound is good. Hello, regulars. Hello, everybody. OK, awesome. So I think I got everybody that was in the chat. Thank you all so much for tuning in. It looks like my head's getting cut off. I think the camera might be a little too zoomed in, but that's OK. Today's stream is on Space Invaders. Let me go ahead and switch my screen to the full view here. And this is sort of where we left off last year. And I noticed that the GitHub repo is actually from November. So if you're in, if you want to basically get the code base that we worked with last November, I'll write the URL here in the chat. Actually, if I do that, it's going to screw up the chat overlay. Basically, it's Coltonoscopy, github.com/Coltonoscopy, that's my GitHub handle, /space-invaders-stream. And then that will give you the code base that we worked with last year in November, where we basically had the following working. Let me go ahead and run this. So it's not really super feature-rich yet. We do have a ship that can move around. And if you press spacebar, you shoot lasers, you shoot projectiles. But it doesn't do anything beyond that. The projectiles don't collide with the ships, and the ships are static. They're basically just sprites that are being rendered. And that's pretty much it. That's pretty much all that's going on. 1 second. But yeah, not a whole lot really going on there. But today's goals are, we have a few goals, actually. First goal is actually get the ships to do something, to move around left and right. The next goal will be, once they're moving, to actually have the projectiles collide with the ships in order to trigger a death, essentially, and to give us some sort of score. And then another thing that we want to do is the game is currently in just a single state where we sort of start the game up, the ship's there, all the enemy ships are there, and we do stuff, but there's not really a title screen. There's not like a game over screen, anything like that. So I would say that our goals today are sort of triple faceted. We want to get the ships to move, get the ships to sort of come down towards the player, move left and right, which is how it worked in the original Space Invaders. Then we want to have the projectiles that we shoot from the player not only dispose of themselves after they've gone past the edge of the screen for performance reasons. If we just let an unlimited number of projectiles exist when we shoot, eventually we'll theoretically run out of memory, although it would be very difficult to do that because the projectiles currently are so small. I'm not sure exactly how many bytes they take up offhand, but relatively few per projectile. But it could eventually end up slowing down the game, and they'll exist and they'll update every single frame. And really, the updating of the projectiles is probably going to be more of a performance issue than the memory cost. Because in our code, and I have to sort of remember how this whole works, but we do have, let's make sure it's an update. In our update function on line 51 to 53, and I'll answer some of the questions in the chat in just a second. But on lines 51 to 53, we have this sort of for loop that says for every projectile in a table of projectiles that we have sort of created in advance, an array of projectiles, you can think of it as. We want to call this update functions. Update function essentially just moves a projectile up or down depending on its orientation, whether it's going up or whether it's going down, whether it's going towards the enemies or whether it's going towards the player. And so for every projectile we add to this array of projectiles, it's going to add more work that gets done in this loop. And eventually this loop could get cumbersome and bring us down from 60 frames to maybe 58 frames, 40 frames. It would take a lot of projectiles to do that. I'm sure it would take thousands of projectiles, but it's something that feasibly could be done. So essentially what we want to do is when a projectile goes beyond the edge of the screen, if it doesn't hit an alien, we want to get rid of it. We want to just essentially set it to nil in the table or repurpose it. You can use what's called an object pool. We're just going to delete it essentially and then just create new ones as we press spacebar. And so we'll only ever have maybe 5 to 10 projectiles max on the screen at one time. But that's something that you want to take into consideration if you're spawning objects. You want to despawn them, sort of like freeing memory in C. Whenever you malloc memory, you have to free it in order to prevent memory leaks. It's kind of the same idea, although a little bit more, I guess, complicated in this sense because you're actually dealing with things that are taking up CPU cycles that are moving and doing stuff every frame. But that's the projectile side of it. The ship side of it, we just need to have a loop where the ships kind of move left and right and come down when they've moved all the way to the edge of the screen until they reach the player, essentially. And then the last part will be using what's called a state machine, which is a very important concept in game programming, which allows us to divide up our game into multiple different states that function sort of as modules. For example, a title menu state, a game state, a game over state. Rather than put all this logic in our main.lua and bloat it unnecessarily, we can sort of divide it up using a state machine class, which we'll implement from scratch here in a little bit. And this is a very effective technique for modularizing your code, and you can use it to not only create states for the game itself, but for individual entities within the game. For example, an entity might be in an attack state, or an idle state, or a moving state, anything that you can think of. If you can sort of create a state for it and piece it out, it makes your life a lot easier when you're dealing with the actual editing of the code. And you can let other people, therefore, edit different states independently. Bavik Knight said, yeah, he's in the CS50W course, the web course, right now on hold, concentrating on algorithms course of Princeton, taking on a massive load. Kirby the Donkey says, what language are you using? This is in Lua. So Lua is a scripting language. We are using Lua and also Love2D, which is a framework and sort of an engine for developing 2D games using Lua. Lua is the language, Love2D is the actual framework, the functions, and the runtime that allows us to do all of the things that we can, all the graphics and sound and input and all that stuff. If you haven't downloaded it already, go ahead and go to love2d.org and grab the version most appropriate for your operating system. And also, if you haven't seen this, for the first part of the stream, you might want to go back and look at part 1, because this is a continuation of that. And we're using that code and sort of building on it and adding the new features. But that's on our Twitch channel and our YouTube. You can look up CS50 on Twitch Space Invaders. You can go on our Twitch VODs and pull it up there. But we have all of the stuff that we did in November of last year, the Space Invaders Part 1 on GitHub. the Space Invader stream. So you can clone that code and also add the stuff that we're going to be talking about today to that. And Tuxman29 also said the same thing. Andre says, Unity's animator controller is essentially a state machine, although it does allow blending animation, so not strictly a discrete state machine. Yes, and Andre and Irene actually made a clone of a game that I created for our games course using those animator controllers. If I'm not mistaken, you use those to sort of replicate that in Unity 2D, which was a really cool project. I saw it on Facebook. And I believe I commented on it. I'm not 100%. I believe I commented on it. Definitely hearted it or liked it, one of the two. But yeah, so thanks everybody for joining. If you have any questions, definitely toss them in the chat. Watch the prior stream if you're not familiar with this stuff, maybe before digging into this one. On Thursday, we'll have, on Friday, we'll have a completely different kind of stream with David. David will be joining us to talk about Docker. So that'll be very interesting. And then we'll get into our routine again where we have these weekly going forward, although the schedule itself is kind of in flux at the moment. So the three goals, again, to recap, are get the ships to move, get the projectiles to collide, and then get the game to exist in multiple different states, not just a regular game state. So the first thing that I probably want to do is work on the aliens, get the aliens to actually move left and right. And right now, if I just rerun the game, and again, for those unfamiliar with this, I'm using VS Code as my editor. You can use whatever editor you want. It has built-in macro for running Love2D from the text editor itself. You can hit Command-L or Alt-L on a Windows machine in order to do it. And I think on a Linux machine, you can probably do something similar. So I don't have to click and drag my main.lu or my folder onto like a shortcut on my desktop or whatnot, or on my dock. I can just hit Command-L, run the game, and it's super fast. So I highly recommend VS Code for that reason for Love2D development. So currently, these are the ships. These are the aliens in question. And I want them to sort of move from top to bottom, left to right, sort of back and forth, almost like, not like a scan line, strictly speaking, but kind of like a double, I guess, bidirectional scan line, in that it'll kind of go like this, almost like a snake-style movement pattern, which is how they functioned in the original Space Invaders, if I'm not mistaken, which was a project that we created for the games course last spring, 2018 spring. So essentially what I want to do is I just want these on a tick, on like sort of like a frame, an interval, a time interval, to move maybe 50 milliseconds, 100 milliseconds. Or that might be too fast, maybe like 300 or 400 milliseconds. I want the ships to sort of move in like little chunks. And then once the far right alien has touched the right side of the screen, they should all come down and then start going the other direction, then down and go the other direction, and so on and so forth. So I kind of want to, in that case, check to see, have kind of like a for loop to check to see if the far right alien, if the direction the aliens are moving is right, check the far right alien. If the far right alien is at the edge of the screen, move everyone down, set the direction to left, and then do the reverse logic when the aliens reach the left side of the screen. Check to see if the far left alien is at pixel 0. If it is, bump them all down, and then set the direction back to right. Andre says, yep, exactly. We used your course's assets for Breakout and used the animator controller to actually control the game's states. Yeah, I thought that was a super cool re-implementation of that project from the games course. So thanks for doing that. Definitely toss, if you have a link to it or to the Medium article you guys wrote about it, definitely toss that into the chat so everyone else can take a look at it. But yeah, so let's go ahead. I haven't done too much review of the code base since we last looked at everything. So let's just go ahead and take a look at what we have going for us here. We have the ship class. So the ship class was what we used to actually control the player. And it just moves left and right. So that's why we have an if, else if for moving left and right. If love.keyboard.isDownLeft, then set your rself.x to be no farther left than pixel 0 using math.max. If love.keyboard is down right, do the opposite with math.min, making sure it doesn't go past the right edge of the screen, minus the ship's width, or alien size is the constant that we use for that. And then if we press the space keyword, space key on our keyboard, notice that here we're doing table.insert. Remember in Lua, table.insert is how we add something to an array or a table. They're all tables, but we can sort of conceptually think of them as arrays or hash maps depending on the particular use case. In this case, table.insert is going to insert into something that we've called projectiles, which we pass into ship update up here. projectiles is being used as an array. I guess more like a Python list than an array, than like a C array, technically speaking, because when used like this, when using table.insert, it will dynamically grow, but arrays don't dynamically grow, at least in C, most static languages. So in this case, we're using it as a list, and we're just creating a new projectile using this constructor here. Projectile taking in our self.x and self.y minus projectile length, so that it spawns at the top of the ship, at the ship's position. And then notice that we're passing in a string up, which is just how we decide we want to tell this constructor which direction that projectile should go. Should it go up? Should it go down? You can use strings. You can use integers. You can use constants that you've defined to be strings or integers, however you want. I like the readability of strings. And it's actually fairly, what's the word I'm looking for? There's a word I'm looking for to describe whether something is often adopted in a particular, I guess, ecosystem or community. Conventional, that's the word I'm looking for. I can't think of words too well. It's conventional in the Love 2D scene to use strings that tell the function or the constructor how something should operate. For example, love.graphics.rectangle is a function that will draw a rectangle on the screen. And the first argument of love.graphics.rectangle, like so, is a string that can be either fill or line. And so that's an example of using a string in the Love 2D sort of ecosystem. And that's kind of why I tend to like to do that sort of thing as well. Oh yeah, Andre's saying, Irene wrote up using the animator controller as a state machine on Medium and posted the link in the chat there, as well as the GitHub link for the project. So check that out. If you're interested in Unity and interested in state machines and Breakout, which is a game that we implemented in the games course, definitely check that out. It was super cool when I saw it. Unity is a really awesome editor, really awesome tool. So this is the ship class. So this is where we create and really our ship class is almost completely done at this point. We will need to check to see if a bullet collides with us, but we can do that in our main.lua. And if it does collide with us, then we want to essentially lose a life and go to the, I guess we can make a simple version and go straight to a game over if we get hit one time. But in actual Space Invaders, you have multiple lives. And so what we want to do in a fully fleshed out version of this would be to go to a separate screen that just says you have 2 lives left or 3 lives left or whatever, current score. And then after maybe 3 seconds, go back to the game, which is kind of how the actual game works. The projectile class is here. The projectile class is pretty straightforward. It takes in a x, y, and a direction, which we just looked at from the ship class. So self.x is x, self.y is y, pretty standard, setting member variables of this class. If you're unfamiliar with object-oriented programming, you can think of a class as a blueprint for how an object should behave, what parameters it should take, the functions that define how it should operate. It's fairly common in games to have classes that all have an update and a render function, so that in your main.lua or wherever your main game loop is, you can just iterate over every object in your game and call update in the update loop and call render in the draw loop. And if we go to main.lua, for example, we can see we do have a update function here. Function love.update takes in a delta time parameter, dt. This is provided by Love2D. And in this, we can see that we do call ship update, which is from our ship class. We call a for loop on all our projectiles, and on each projectile we call update. And then we do something here where we reset a global table for keyboard input so that we can test for discrete keyboard input outside of main.lua. And if you're unfamiliar with all of this stuff, a lot of it is explained in much more detail in the first part of the stream. This is not an advanced stream, I would say, but a more intermediate level. Certainly, if you're going into this blind, I would check out the first stream a little bit more. It'll go on YouTube if you want to watch the first stream and come back to it later. So definitely feel free to do that. But paired with that update function, very importantly, is our draw function, love.draw. And these are functions that Love expects to exist in your main.lua file. And note that we are indeed looking at our main.lua file. This is the main file, hence the name, that Love2D looks for when it runs your game. So this is sort of the starting point, just like in a C program where you're looking for the main function, or a Java program where you're looking for the main function in a class. or even Python, if you're running a module and you have if name is equal main, that's sort of the same idea. Main.lua is that starting point, and it expects a certain set of functions to exist. And if you don't define them, your game will not run them, and therefore it will not function like you want it to function. Love.draw is a function that just is supposed to take care of all the drawing stuff to the screen. So everything updates first, and then everything draws to the screen. Right? So you move your ships, you move your projectiles, you figure out if things have collided with each other, and then you draw them to the screen, or you don't draw them if they've been, for example, removed from the scene because maybe your ship got blown up, or an alien got blown up, or a projectile is off screen. You don't draw it anymore, right? So here we're calling push start and push finish at the start and end, which just gives us a virtual resolution. Again, we cover that in the first part of the stream. We clear the screen. We do a loop over all the projectiles, just like we did in update, but in this case, we're calling render on all of them. And render's job on each class that we define it is just to draw whatever class it belongs to, draw that information onto the screen. In this case, we're setting our color to red, or using a rectangle. Again, love.graphics.rectangle, which we just looked at. It takes in a fill string, an x and a y. This one is I'm trying to remember. That's the width in pixels. So we want a 1 pixel wide rectangle and then a projectile length, wide length, height of our rectangle, right? So it takes an x, y, width, and a height. And I guess 1 should probably be projectile width as well, a constant. But since it's just 1, I guess I thought 1 would be good enough. Nawanda333, that's Astley, says, hi, Colton and everyone. Thanks for joining, Astley. Good to see you again. Happy New Year. And here we see that we're setting our color to 1111 after we finish drawing the rectangle. And that's to revert our color, our sort of global state for Love2D. It always has one color it draws stuff with at a time. We set it to red here. We draw the rectangle. And then on the line after the rectangle, we set it all ones, which is all white. So the newer Love2D versions, Love 11 and onwards, they use from 0 to 1 to create colors. You might be familiar with RGBA, which takes in, well, RGBA is what we're using, but you might be familiar with 256 valued RGBA. So start at 0 and at 255. That's how Love2D used to do colors. So in the old version, you would say 255, 00, 255. And that would be the same thing as the current version of 1001. But in version 11, they changed it all to from 0 to 1 floating point values. So I could say 0.1, I could say 0.15. It's more efficient. I have to I'd have to look back at the reason as to why exactly they had to do it. It's, from what I remember reading about, it's a performance reason, and it also helps with shaders. And underneath the hood, it's just more performant. But offhand, I don't have the exact reason. People joking in the chat about bringing pizza from an old sort of stream we had where Astley kindly offered to get pizza for everybody, which I'm not sure if that offer still stands. Hopefully it does. Also, I think we were looking at projectile earlier before we went back to main.lua. The projectile update function is just an if-else statement that basically says if our direction is up, then every time we update, we want to essentially decrement our y position, which is what we do here, self.y equals self.y minus projectile speed times delta time. Again, anytime you need to update something in a game, or at least in Love2D typically, in most games, in order for it to run at a consistent frame rate, every time you move something or do something that can be variable, you want to multiply it by some constant value, some value that's dependent on your frame rate. In this case, delta time. Delta time will be different depending on how many frames have elapsed since the last frame, whether it's usually 1, sometimes it can be 2 or 3. It's some floating point value that you can scale movement by so that 2 computers at different speeds will run your game, and things will move at the same speed, even if one is more jittery than the other one, essentially. And that's why we are multiplying projectile speed times delta time. So that's the projectile class, the ship class. The alien class is empty. The entity class is fairly empty. This is the base class from which we inherit the base class which we superclass the alien class from. So notice in this particular module, alien gets class This is the library we're using to use object-oriented programming in Lua. It's not something that you get by default. Again, I apologize if all this is a little too much review. I just want to make sure we're all on the same footing, and this also kind of helps me remember the code base a little bit more. But Alien is a new class, and it includes everything that's in Entity. And this is part of the class library that we used last stream. So includes Entity, and this is the class from which we want to take all the stuff that exists in that class and create a new class from it. So Entity is this class. So aliens all have this constructor, xy_sprite, and they also have this render function, which draws from our global textures variable in our dependencies. This is dependencies.lua. It has all of our libraries here using require statements. It also has a global textures table here, so we can store all of our textures, all of our 2D images. And then we can store our frames, so all of our actual sub-images on those textures. And we talked about this last stream as well. In this case, we're just using a image in our graphics folder. Suratan says, I've just downloaded the 2D Engine. What was the name of the editor you're using? I know you mentioned it. Sorry, I forgot the name. No worries, Suratan. It's a VS Code. So Visual Studio Code. It's a very popular Microsoft editor. You can get it by going to code.visualstudio.com. Super awesome text editor. You can also use Atom. You can also use Sublime Text. They all sort of have the same feature set, but different plugins often. I haven't used Atom in a little while. I imagine they probably have something similar to the plugin that I'm using for Atom. If you want that plugin, it's the Pixelbyte plugin. So if you're in Visual Studio Code and you go to the extensions area, get the Love 2D support plugin by Pixelbyte Studios. Awesome plugin, super recommended if you're doing any Love 2D development. Let's go back to here. Wrong click there. So this is our dependencies file. Stores all your dependencies, all your libraries, all your textures, all your sounds, all your frames, everything that you want, all your assets and libraries. I like to put them in a dependencies file, but you could also just put this all in your main.lua, and it would be totally fine. Not what I would recommend, just because then it gets a little bit bloated. I try to keep my main.lua fairly clean. So notice it only has, at the top, require source dependencies, which basically imports all that stuff that we defined in dependencies.lua. And then we just have all the core functions that we need for our game engine, all the core loops. And then we defer all the actual logic as much as we can to the classes themselves, the projectile class, the ship class, the alien class, entity class, all that stuff. And our main.lua file ends up being currently less than 100 lines of code. Will probably be a little bit more than that eventually, hopefully not too much. In our main.lua, the actual aliens themselves get generated in our love.load function. So love.load is a function that exists at the beginning of doesn't have to exist in the beginning of the file per se, but it exists, it triggers at the beginning of your Love2D application running. So before you start updating, before you start drawing and checking for input, you'll call love.load. Love2D will call it for you. You have to define it. But this is all the stuff that you want to happen before you update, before you start drawing, all that stuff. In this case, we do a bunch of initialization. We set our filter to nearest, which allows us to be everything to be very pixelated. And actually, this, I realize, needs to go in dependencies.lua before we actually import any graphics. So what I did was I took that love.graphics.setDefaultFilter function, and I put it before we load any textures. Because on certain computers, what this will do is, even though you call default filter nearest, we were doing it technically after the texture was loaded. And as a result, certain computers will show the aliens as being blurry. So put this before we actually load the textures to prevent that issue. And I took it right out of my love.load function here. There will be no change on my computer because, for some reason, it works fine on my computer. The nearest thing doesn't cause any issues. It might be a result of the push library overriding that. But on certain computers, if you're using a newer version of the push library or your graphics card is funky, it'll look kind of blurry. So if that happens, just do what I just did. OK. The moment you toss pineapple on a pizza, it becomes a sandwich and not a pizza, says M. Kloppenberg. We got a war on pizza in the Twitch chat. Yeah, a long pineapple pizza conversation going on, which is good stuff. Dan Coffey, CS50's Dan Coffey, who did a stream last year on Draw50, which is an awesome tool, which we actually used, I think, last Space Invader stream, is a huge fan of pepperoni pineapple. So if Dan's looking in the chat, shout outs to Dan and his pepperoni pineapple pizza. Not sure if that's been mentioned, if pepperoni pineapple specifically was mentioned. I think it's just pineapple and pizza generally were mentioned. So anyways, back to love.load, which was where we initialized all of our aliens. We also initialized our ship. And actually, shout out to Asley and Bavik, who are in the chat right now. We, last stream, ended up having a mini war on which ship we wanted to use at the start of the game, the player ship. So I think if I run this over and over again, we see right here, this little ship here, this little red ship, is going to potentially change to another ship. If I keep running it, it's random. Yep, so right here. So I don't remember offhand which one Asley chose, which one Bavik chose, but they both had a different ship that they wanted to use, and we ended up using a little math.random2, which just gives you a value between 1 and 2. And basically used a ternary, the Lua's ternary statement, which is an and or, and well, a conditional and then an and an or. And then what we ended up doing was the game will randomly choose between Asley's ship and Bavik's ship. And their ships are just frame indices. So if we look at our file here, let me go into Space Invaders, graphics, aliens. I think it was aliens 6. No, it was aliens 12, I believe. I'm not 100%. I have to re-look and see. Was it 12? Might have been. Oh, yeah, it is 12, because I recognize this ship here. Essentially, all of these individual ships on this one texture, this one 2D image, can be, you can split this image up into rectangles, and that's what's called, it's called using a sprite sheet. In Love 2D, they're called quads. They're rectangles that define a sub-image on a 2D image. And what we can do is we can assign each of these an index between 1 and however many ships there are, counting top to bottom, left to right. And by drawing our 2D image in Love 2D and then referencing a quad, we can draw that sub-image. And all the quads are, we split it up by 12 by 12 pixels and put them into a table, so a one-dimensional table. And so therefore, it's from 1 to, I think this is 1, 2, 3, 4, 5, 6, 7, 8. It's 16 by 16, 256 ships long, so between 1 and 256. By assigning a particular index and then drawing love.graphics.draw, we can draw a particular sub-image. And so that's what we're doing here. We're getting an image, or getting an index. So we calculated the number. We figured out what row it was on, 16 by times 3, and then the 6th one over is 16 times 12, and then the 9th one over. So 3rd row and then the 12th row. And that's effectively how we did that. That's what that bit of code is there for. We instantiate a ship. We put it in the middle of the screen, which is what this logic here does, virtual width divided by 2 minus alien size divided by 2. Alien size is, I believe, 12 pixels. All of the capitalized things are in constants.lua. Excuse me. Constants.lua is a good place to store constants. Constants are just variables that should not change. Lua does not enforce using constants, so you have to kind of use programmer, I guess, heuristics in order to use constants appropriately. In this case, we do that by capitalizing, as is conventional amongst many programming languages, the variable name and using underscore notation. So anything that we see that follows this variable naming convention, we can assume is a constant and should not be assigned a value, only used read-only in our code. In this case, alien size is a constant. It is 12 pixels. Virtual width and virtual height are the dimensions of our virtual resolution. It's how we make our screen look as if it's retro, even though it's not. And there are some other ones here. Projectile length. We don't have a projectile height, but just for a good measure, projectile height is 1. And then we can use that in the future when we reference that. Yeah, Colton being very diplomatic about the ships. It's very important that we embrace everybody's opinions. Whoa, he multiplied it in a second. Someone brushed on math during the holidays. Oh, yeah, because last year I was not able to, on the fly, figure out what 16 times 16 was, and I was made fun of for it. It's 256, something that most programmers should probably know, and I was not included amongst that category of programmers, unfortunately. OK, so I think we've done a rough recap. The last thing I think that we need to talk about is the actual loop here that initializes the aliens. In this case, alien is just an inherited version of entity, so it's not really that different from an entity. It's actually a pretty empty class. And what we're doing here is we're instantiating it at an xy with this for loop, aliens tall, aliens y. That's how many aliens fit on the screen. Sorry, that's not how many aliens fit on the screen. That's how many aliens we want in our set of aliens. We're doing a nested loop, just kind of like how we do in Mario for y is 1 to aliens tall, which aliens tall is, we decided will be 5. So we want 5 by 11 aliens. We do that in a yx loop, and then we insert an alien into our aliens table. Alien, just another table, just like projectiles, sort of stored the same way, or functioning the same way, in that it's one-dimensional, and that we just iterate over it. Each alien maintains a reference to its own xy position. And alien is a class which takes in an xy and a frame. So frame is the number between 1 and 256 that maps to our 2D texture, all of our quads, right? And our quads, again, are this gframes table on line 22 in dependencies.lua. On line 23, we can see we're assigning aliens, the index string aliens, to the result of a generate quads function, which we wrote last week not last week, feels like last week, which we wrote last November. If we go to util.lua, that's where our generate quads function is. It just splits up a texture into quads based on how wide and tall each sprite is. In this case, the sprites are 12 pixels by 12 pixels, so that's how we split it up. Cure have no mana. Thank you very much for following. Hope I pronounced that right. I imagine I did pronounce that right. And 08 Rock, if I missed you, apologize. Thank you very much for following as well. All right, so I think that's a fairly solid recap. I apologize if that was a little bit cumbersome for everybody. If you're already familiar, if you're brand new to the stream or brand new to this game, then that might be of some help. Certainly, I need it getting back into the code base. But I think we have enough information now to where we can decide how we want to go about moving our sprites, right? So the first thing that we can do is in our main.lua, we do have access to all the aliens, right? So what I can do is, and we probably want this to be in our update function. So the first thing that we can probably do, well, first thing that we should do is we're going to need a variable that keeps track of which direction the aliens are moving in, right? Because they can move to the right, they can move to the left. Your right, my left. To the right, to the left. So what we can do is I can just call another variable, and ideally this will all be sort of encapsulated within a game state, and we'll talk about game states a little bit later. And then maybe even in future streams, we'll implement things from a more state machine focused approach from the beginning, as opposed to this sort of ad hoc, everything in main approach. But we kind of have to work our way up there, I feel like. It might be a little bit too much to jump into that right off the bat. But what I want to do is I want to create a variable called alien direction, and I'm just going to assign it a string called right. And again, using strings as the way of classifying our variables, because strings kind of make sense. Oh, they're talking about the sound. M. Kloppenberg, Nwanda, and Andre says the same sound from Khan Academy for following. Yeah, it's. I had thought that we had used that follow sound for a long time. It may be the case that you all didn't hear it prior to this stream. We reconfigured our audio setup a little bit, but it's just a follow sound that OBS, or I guess Twitch, lets you have in your channel every time someone follows or subscribes, all that sort of thing. So it's a nice little sound effect. I like it. When I hear it, I know that I have monitors back here, so I know that somebody's followed, so I can look up at the screen and see and thank them. So it's pretty great. So we have a variable called alien direction that we've declared in main.lua, which is going to be the direction that the aliens move each frame until they reach the end of the screen, and then it should get set to the other direction. When it gets set to the other direction, they should move to the other side, check to see if they reach that end, and so on and so forth. And then when they do reach either end, they should all move down. They should get closer to the player. That's how the game works, the actual Space Invaders game works. So I can say if alien direction is equal to right, again, just comparing it directly to the string right, because it's going to equal either left or right. Excuse me. And I'm going to preemptively say an else here. It can only be right or left, so we don't need another conditional statement. We can just say else. What I want to do is I want to set every single alien's position to the right just a little bit. Well, I should say, I don't want this to happen every frame. I want this to actually be on a timer. So what I should do is, now do I want this to be using a timer library? Probably not. Probably not yet. That might be a little bit too much. So I'm going to say alien movement timer is 0. And then I'm going to say in our constants, if I can, I don't have constants open. Constants.lua, I'm going to set a alien movement interval. Oh, that startled me a little bit. DJoker07, thank you for following. That name looks familiar. I thought that DJoker was already following, but if not, I apologize. Alien movement interval, I'm going to set that to be, this is in milliseconds. So is it in milliseconds? No, I think Love2D measures dt in fractional seconds. So let's say I want the aliens to move every 0.4 seconds. And again, this is a constant. This isn't going to change. I could make this a variable that does change if I wanted the aliens to move faster the closer they get to the player, which is kind of, I think, how it works in Centipede. No, it's not how it works in Centipede. I don't think so. I think it just looks like they're moving faster. I don't remember offhand. But basically, it's going to be a constant in this case. And the timer itself is going to keep track of how much time has passed each frame. And we're going to add to it. And once alien movement timer is greater than alien movement interval, which means 0.4 seconds have elapsed, then I should move all the aliens to the right or to the left, do the condition to check see if they've reached the edge of the screen. And then I'm going to reset the timer back to 0, or at least back to timer minus alien movement interval in case they went over 0.4, just a little bit, right? And shout out to David in the chat. Says thanks for tuning in today, everybody. Thanks so much for tuning in as well. DJoker07 says Happy New Year, Colton. Thanks, DJoker. Very much appreciated. Everybody's talking about their amount of RAM, 16 gigs. If it's an idle, it won't take any RAM, says One Day My Love. I might be lost in the conversation there. Oh, 2 instances of Unity open plus 1 instance of Blender. And everybody's saying hello to David. Awesome. Cool, cool. So we have a timer now. We can keep track of how much time has elapsed since the last frame. We can cumulatively add this until we've gone past that amount of time. So what I'm going to do is, before I actually, well, I'm going to keep the if statement there, but it's actually going to be nested within my other if statement. I can say alien movement timer gets alien movement timer plus dt. Right? Remember, dt is a variable that we get every frame passed into love.update by the Love2D framework. And this is going to be measured in fractional seconds. So it's going to be 0.013 or 0013. I forget offhand. I think it's 0.013. And if alien movement timer is greater than or equal to the constant that we've defined, which is alien movement interval, then, and this is where we nest that bit. So I say if alien direction is equal to right, so if they're going to the right, what we need to do is we need to increase every single alien's x position, right? So that means we need a loop. So I can say for underscore alien in pairs aliens do alien.x is equal to alien.x plus, and then we have to figure out how much we want to move the alien by. So I guess we can say alien alien size, alien step length. We'll call it that, alien step length, and we'll say that's going to be 5 pixels. I'm not entirely sure. A lot of this you're going to have to kind of do by feel too, especially if you're doing things that are based on time, when you're moving stuff, getting speeds right. It's a little tricky to kind of guess everything correctly right off the bat unless you know your specs in advance. I don't know the specs in advance, so I'm just going to take a guess, and then we can fine-tune it as we need to go along. And this has a role to play in game balancing, because this movement of the alien X, if it's too small, the game will be too easy, because the aliens will take a long time to get to the bottom of the screen. If it's too big, the aliens will get to the bottom of the screen really fast. And as a result, it'll be harder for the player to defeat all of them in time. So we need to sort of keep this in mind as we're balancing the game out, tweak it, play test it, get a sense of it. This is part of the QA testing side of making a game. So we're going to say alien step length. So we have alien.x is equal to alien.x plus alien step length. And this pairs function, again, is how you iterate over tables in Lua. So it takes in a table, in this case aliens, and will give you every single alien, every single key, and every single object within that, every key value within that table. In this case, all the values are aliens, alien objects. So we do that here. And then we do the same exact thing here, right? Except instead of setting the alien x equal to alien x plus the step length, we want to minus the step length. So they move to the left instead of to the right. And again, you guys are, it's mirrored to you, to the left, to the right. But I have to think of it the opposite way. Someone, I can't see that name. It's in black text. Winlagon, happy to be here taking CS50 GD at edX. Awesome. Thank you so much. Well, glad to have you with us. Winlagon. Log on. I hope I'm pronouncing that correctly. I'm probably not. Colton saying cool, saying like Jake Peralta. I'm not entirely sure who that is. I should look that up. Cool. So this is how we move the aliens on a timer. And then once we have moved all the aliens, we want to set alien movement timer to alien movement timer minus, what's it called? The alien movement interval. That way, in case we do go over 0.4 to like 0.41 or something similar to that, it'll take that into consideration, that overlap into consideration, and we won't kind of get extra time added to our loop, which is what you do if you just set it to 0 and don't account for that overlap. So alien movement timer gets alien movement timer minus alien movement interval. That's great. So it'll roughly be 0, if not 0.01, 0.001 or something like that. And that will move the aliens to the right and to the left. Now, if we run this, it should work. They'll move. So this is roughly what we want things to look like. It might be a little fast. But notice that when they go to the right edge of the screen, they just keep going forever because we haven't actually implemented checking for the edge, right? So that's something we want to do. We want to say if the far right alien is at the right edge of the screen, then set everything down, shift everything down by a few pixels, maybe even the step length. We could do that, or maybe step height. Maybe we want to define step height as a separate constant. So I can say step height, and maybe we want that to be 8 pixels, a little bit more than the step width. They're moving a little fast, so I think the interval should maybe be 0.5 seconds. We'll see if that's any better. That should be fine. This is a lot up to your tastes more than anything, so you kind of want to tweak it depending on what you like best. So we've done that. We've got the aliens moving. Now we need to actually figure out when the aliens are at the edges of the screen. And for that, what we can do is we're just going to assume that all the aliens are sort of, even if they're destroyed, they're there. So we can always test the far right alien, and we can always test the first alien to be our left and right edges, right? So our alien, or rather our far right alien is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, our 11th alien. So we can just kind of know our 11th alien will always be where we can indicate the right side of the screen. So I'm going to say if aliens at 11, so because we added to our table, actually I'm going to use best practices here. I'm not going to use 11. I'm going to use far right alien and far left alien. And aliens wide is also the same index as far right alien in this case, but we're going to separate them just so that our code is more readable. This is important. You want to make variables that are readable so we can, at a glance, know that we're checking the far right alien here. We're not checking some random 11, which doesn't make any sense. Just reading it offhand if you're not familiar with the code base. So if far right alien dot x is greater than or equal to, and this is where we want to check to see if it's at the right edge of the screen, right? So we're moving right. So I want to say if aliens far right alien dot x is greater than or equal to virtual width, that's the far right edge of the screen, minus alien size, then, and minus alien size because we want it to be when the right edge of the alien touches the touches virtual width, not the left side of it. Remember, everything in Love2D is based on its top left coordinate. So the x, if we check for virtual width, just virtual width, the alien will get all the way to the right side, like past the right side of the screen before it actually checks the condition. We want it to check when the right edge of it touches virtual width, right? So I'm going to say if aliens far right alien dot x is greater than or equal to virtual width minus alien size, if the alien is right at the right edge of the screen, this is where we want to set the direction, which the variable is up here. It's alien direction. We're going to say alien direction is equal to left. It's no longer right. We're no longer moving to the right. Now on the next frame, this is going to be false, and this is going to be true, and it's going to tick all the aliens to the left. And this process will continue, assuming that we flesh out this if statement here, this else statement. This will continue infinitely. So what we can do is then say alien direction is equal to left, and this will have the result of, it could be possible that the aliens move slightly past the right edge of the screen, and we need a bit of logic to sort of reverse that, but we can solve that. I guess it'd be fairly easy just to figure out what that difference is and then subtract that from every alien's x. We won't worry about that yet. It's not super important. What we're going to do first is just get the loop working infinitely. So in this case now, we want this to be right. So in the else statement, so when they're moving to the left, we still have it decrementing their position, but now we don't want far right alien to be tested for. We want far left alien to be tested, and we want it to be less than or equal to 0, which is the left edge of the screen, not virtual width minus alien size. Now we're checking to see if the left side of the left alien, the leftmost alien, the first alien, is right at the left edge. So if aliens far left alien dot x is less than or equal to 0, then alien direction is equal to right. So then we're going to go back to the right. And we're missing one last step, and that is we want every alien to move down when this happens. So what we can say is, again, another loop for underscore alien in pairs of aliens. Do alien.y equals alien.y plus, and then we just defined it, alien step height here. And then I want to bring this same exact code over here, just like that. So if everything is according to plan and my logic is correct, when these aliens reach the far right side of the screen, they should bump down. Let's test and see. Yeah, it looks like it jerked a little bit to the right there. A little funkily. So yeah, that's the, am I changing all of their thing to the right size? I might want to do greater than, not greater than or equal to, so that it doesn't do that weird sort of diagonal jump. Let's see if that fixes it. No, I don't like how that looks. Looks a little bit weird. This might be acceptable for now, just in the sake of time. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, boom. Yeah, another thing you could do is you could count the number of steps that are ideal between each oh, actually, do we want to do... If we do this logic before the aliens move to the left and the right, it might look a little bit better. And then do an else, like that, and indent that. So this way, the aliens will move all the way and then set the direction and then skip that iteration so that it looks a little bit more like the original game. See if my logic is correct. If not, I'll just revert it and we'll accept it for now. It's a little, it mechanically needs to be adjusted a little bit, but the logic works. It just doesn't look perfect. But I worry if we spend too much time, because we're already an hour in and we have collision and game states to worry about, we might not have enough time for a 3-hour stream, but we'll see. So let me go ahead and do what I just did again. OK, else, indent this, and let's try it. Let's see what this looks like. Hopefully this looks acceptable. If not, I'll have to just revert. Oh, that looks great. OK. Does it look OK on the left side, too? It's OK. It could be a little bit better. I feel like I need to maybe change the left side so that it's checking for like 2 pixels instead of 0. Because it goes a little bit past the left edge. Yeah, like 4 pixels. So if I do single to 4, see if that fixes it. While that's going, I will read the chat, or at least try to. Ever heard of byte paths as one day my love? I'm not familiar with what that is. Oh, that looks great. OK, now let's see. Since now it's going off of 4 pixels, see if it screws up the right side too. Hopefully not. Nope, that's excellent. OK, cool. This looks awesome. So let me read through the chat here. So I missed one day my love saying ever heard of byte path. I'm not familiar with what that is. I apologize. Bevig Knight says, maybe we can make it variable and make levels in the game with level up. We can increase the speed by some amount. Yeah, we could do that. I recommend definitely taking it and trying to do that yourself if you can. I don't think we'll have time. I don't think I'll have time to implement that on stream today with the other stuff that we want to implement. But it's a great exercise, certainly. And I think we've done something similar to that before with Snake. I think we did levels and stuff. ISO TV, hello everyone, Happy New Year. Sorry I'm late. I was on vacation till today. Did I miss anything special? So good to see you, ISO. Nothing too special. We did a review. I imagine you probably saw the last Space Invaders stream. I don't remember offhand. If you did, then most of what we talked about for the first hour was review, or not first hour, for 40 minutes or so was review of the code base, figuring out what the next steps are, kind of just saying hello, Happy New Year. Now we've actually, for the last 20, 30 minutes, got into the meat of the game. We've added aliens moving. So the next few steps are to be collision detection with bullets, make aliens shoot, that sort of thing. Yeah, and game states. That'll be another thing, yes. Suratan kindly said, talking about what we implemented last year, correct. As it says, why is it doing that jump? The logic was a little bit screwy. It was checking for the, checking to see if, it was basically moving before it checked every time, and so it would move. It would move in a weird position and then jump down, and the logic was slightly messed up. But we fixed it. Everything's good. So now it actually does the check before it adds x or subtracts x from the aliens, and it does it with an if-else, so it won't do them both in the same turn. So we do get block movement on the frames or not the frames, but on the part of the interval where we actually do move the aliens down. We don't move them down and then move at the same time. That was the core issue. It wasn't in an if-else. Now it's in an if-else, so that problem is fixed. Yeah, essentially what Bhavik said, when it reaches either left or right extreme, pause for a time step, go down that time step. That's what we did. Yeah, if-else. Awesome. Cool. So aliens look good now. The movement looks good. The next step is probably collision, right? So I can move around. I can move the ship around. I can shoot. But it doesn't do anything. It actually just goes straight through the aliens, through the other side. And that's not ideal behavior. So a couple things we want to do, as we mentioned earlier, we want the projectiles to be only around as long as they're visible. So when they've gone past the top edge of the screen, if they haven't hit an alien, we want to get rid of them. We want to get rid of them if they hit an alien. And if we hit an alien, we want not only to get rid of the projectile, but also to get rid of the alien itself. So a few steps, a few pieces. This is a long block of code, too, 58 to 86, to do the alien movement. Could separate that out, I guess. So you can call this like tick aliens, and then go down to the bottom here. Just modularize our functions a little bit, see if it still works, which it should. So it's a good habit to make your update and draw functions kind of as small as you can. In this case, we have this big block of code that does something very specific. So tick aliens, we just took it out, made it its own function. Now our code looks a lot more readable. We can say, OK, in our update function, we update the ship, we update the projectiles. We probably can put this in there as well. And then we tick the aliens. So we move the aliens. So boom, that's done. Cool. Essentially just a copy paste out of the update function. It's not better engineered necessarily, but it's easier to read. It looks a little bit better. It's more easy to keep track of what's going on. You're not navigating through a monolithic code base to figure out what the functions do. When you have functions that you can reference by name, you can also reuse them in multiple places if you wanted to and mix and match them. Puzzle pieces. It's useful. OK, so now collision detection with our projectiles. So the projectile class here, what we can do is probably define a collides function. We want a collides function that works with every entity in the scene, because we want to check to see, I mean, essentially we only want projectiles and ships to collide with stuff. So we could just define a collides function on projectile that takes in something that has an x, y, width, and height. The aliens, do the entity have a width and a height? No, they don't. So in this case, we can probably set self.width is equal to alien size. Is alien size the one? Alien size, yeah. It's always going to be 12. But this way, each object has a width and a height now, and we can use that in our collides function. So we go to projectile. I'm going to create a new function called collides. I'll do it before update and render. And it takes in an entity. And this entity is assumed by this function to have an x, y, width, and a height, which is why we just added width and height to entity. The ship and the alien will all inherit from entity. And therefore, they will all have an x, y, width, and a height. So this is AABB collision detection. I think we covered this in a prior stream. I forget offhand which stream it was. Maybe somebody in the chat knows which stream we covered it in. I remember drawing it, or at least I thought we did. Pong. Yep, there it is. OK. Did we cover that in 3D Pong? Did we really do that? I thought for 3D Pong we did Unity's collision system, so we didn't need to do AABB. We cover AABB in the games course for the G50, but for stream, I don't remember if we covered it. Essentially, check to see whether two rectangles, whether one rectangle's opposite edge is past the other edge of another rectangle. That means that they impossibly cannot collide, and therefore it's a simple check. And it assumes the rectangles are on the same axis. They're not rotated rectangles. They're axis aligned, so completely orthogonal. I guess is that the right word? Perpendicular to the axes, orthogonal to the axes. And therefore, it's a very inexpensive operation and a very simple operation. So I can say if self.x is, and so we're checking the left side of the rectangle. So if the left side of this rectangle, this projectile, is greater than entity.x plus entity.width, then that means that this rectangle's left side is beyond the right edge of another rectangle. Therefore, it's impossible for them to collide, essentially, right? And we do that same logic for all four sides of the rectangle. And then if any of these are true, then there's no collision. Otherwise, there's a collision. So if self.x is greater than entity.x plus entity.width, or self.x plus self.width is less than, that's the right edge of the projectile, if it's less than the, oh, this doesn't have a width, width and a height. So we need that as well. So this needs to have a width. So projectile, do I not have projectile width and height defined? Projectile height. Oh, that's not projectile height. That's width. My bad. I screwed up the constant in dependencies. I called it projectile width. Should be, or projectile height should be projectile width. Width and length, which is fine. So self.width is projectile width. Self.height is projectile length. So it's 1 and 5, respectively. Small rectangle. If self.x is greater than entity.x plus entity.width, or self.x plus self.width is less than entity.x, or, fairly long if statement, self.y is greater than entity.y plus entity.height. So if this is below the other rectangle, or self.y plus self.height is less than entity.y above the rectangle, then, oops, then we want to return false, so it does not collide. Else, we return true. Both of these, for a long if statement, it gets kind of obnoxiously formatted. But that's essentially it. Check to see if opposite edges are beyond each other. If they are, it's not a collision. If not, it is a collision. Cool. Simple. And now we can, in our main.lua, say for every alien, or I guess for every projectile, rather, projectile update. Now, the thing is, if we want to update each projectile, so each projectile takes in, it updates, right? So it ticks. It says if the direction is up, move it up. Self.y minus projectile speed times all the time. And the same thing goes for moving it down, right? So we can update all projectiles. And maybe ideally this exists in the update function for projectile. But it would probably be ideal to do that from within projectile, test a collision against each entity, say for each entity in the scene, do this, blah, blah, blah. What we're going to do instead is we're going to do that in here. So we're going to move every projectile, and then since we have access to all the aliens and the player's ship within this function here, since we're in main.lua, we're just going to check this. We're just going to check collision here in another for loop. So we're going to say for underscore alien in aliens, pairs aliens, do, right? So we've moved the projectile, and now we're going to say if trying to think, because if we do that, we also need to get rid of the projectile. So we would have to set that projectile to nil. But we can worry about that in a second. So if projectile collides with alien, do and then, OK, so P key. So projectile key and A key. So that's what we're doing. We're saying P key and A key because we want to have access to the key in the table from which we are calling it. We're going to set that key to a nil value in the instance that we collide the projectile and the alien. And then we're going to also add an if nil check here. This will allow us to set that particular alien to nil, as opposed to, do I want to set to nil or do I set it an invisible thing so that we still have width and height access? No, we don't need to set it to nil. Invisible. Probably want to set an invisible flag on the alien. Defeat it, set an invisible flag. And then once we set an invisible flag, the alien will still exist. We can still update its position. It'll still be hidden. Yeah, that should work. JP Guy says, everybody in Colton, long time no see. Thanks, JP Guy, for tuning in. Glad to see you. Make sure that I didn't miss anything. Hope you had a nice holiday season. Talked about pineapple pizzas and mentioned you. The audacity, says JP Guy. Does Lua have an interface support like Java interface? It'd be helpful in class like projectiles shoot by either of ships or aliens. No, there's not really a notion of interfaces, Bavik Knight. Really, everything is very dynamic, so nothing has to adhere to anything. You kind of define whatever functions. Like the best thing you could get is just by using classes, honestly. There's not really an interface. It's not going to, at runtime or compile time, determine whether you're calling a function that's valid on a class that implements a specific interface, because it's dynamic. It doesn't have that notion. Good question, though. New Year's is old news now, says JPK. It's getting there. It's like, what, is today the 7th, 8th? What is today? The 7th. OK, so back to the code here. So we're declaring P key as the key for every projectile and A key as the key for every alien. Normally, we just use underscores because we don't use the key for anything when we do an iteration. We just use the, so this is to throw away the it's kind of idiomatic. It's paradigm to use underscore in a lot of languages where you just toss a value away, you don't do anything with it. So that's what we were using it for. But now that we need the value, and because we're using a nested loop where we were using underscore, we need to differentiate these two keys, because we will use both of those keys here in just a second. So one thing that we're going to need to do is aliens are going to need an invisible flag. So we'll just say entities can have an invisible flag. And we'll set to false by default. And then if not self.invisible, draw it, right? Because if it's not invisible, we should draw it. OK, pretty straightforward. And then what we're going to do is when we actually check to see if the projectile collided with an entity, we want to check the invisible flag. Because if the invisible flag is true, then we want to ignore the collision. So if projectile collides with alien and alien dot and not alien dot invisible, then we want to say projectiles at index p key is equal to nil, and alien.invisible is equal to true. And I think that should work. I'm not 100%. I might have, it looks like I messed something up. Line 56, if, I put a do instead of a then. Whoops. Arithmetic on global delta time on line 99. How did we do that? Oh, I see. OK, this needs to receive dt, and then we need to pass dt into here. So remember, functions that you declare don't have access to dt unless they're called or referenced within main. So we take dt and we pass it to tickaliens so that tickaliens can do whatever work it needs to do with delta time. So boom. So now if I do that, it works. Awesome. No sound. So will it work with aliens that are beyond? Yep. That's so cool. It works. No sound effects. I feel like sound is always a super important aspect of the game. So I want to make some sound effects. As this is awesome in all caps. Yeah, it's pretty cool. I'm happy that it worked sort of on the first try. I mean, I had a couple of syntax errors, but it works. My logic wasn't wrong. That's the more difficult thing to solve. OK. What sounds good? Let's see. Let's turn this up. Turn my sound up a little bit. We want to. So if you're not familiar, this is BFXR. BFXer, I'm not sure how you pronounce it. It's a sound generation program on Mac and Windows, and I think maybe Linux. I'm not 100% sure. Just generates sounds using simple sound synthesis. Different sound waves that you can use, triangle, sine waves, saw waves, et cetera. They even have whistle wave, which is interesting. They have some preset settings here that are all kind of randomized and tweaked, so it's super nice. I'm going to make a couple sounds. So the first one I want to create is like shooting, like a laser. So they have a laser shoot category here. I couldn't hear that. OK, that was a bit better. That might be a little obnoxious. I'm going to turn it down a little bit. What do you think? Does that sound obnoxious? Sounds kind of nice, right? Use that one. Where are we at? In here. Space Invaders. Oh, yeah. BFX doesn't let you create folders within the interface. So sounds. And then export wave, sounds, laser. Do the aliens shoot back? Yes. Not yet. We will implement that. Sounds, laser, and then we want something for when we defeat an alien. So explosion. No, probably not that one. No. It's all loud. But if we turn it down. A little harsh. That sounds OK, right? Maybe? That sound is so much like the original Space Invaders, though, the first explosion. This one? I, for one, welcome our new alien overlord, says JP guy. Not without a fight. You need a short sound for the explosion. Yeah, I kind of agree. Can I speed up the sound? Yeah, it should be sustain time. Decay time. How's that? They only eat pineapple pizza. Yeah, nice. OK, we'll go with that one. That's fine. So we'll just call that one explosion dot wave. And we'll leave that open in case we want to add some new sounds. I'm going to go to my dependencies. So this is where we have all of our assets. G sounds is going to be a new table. I'm going to create a global table. That's why we're using lowercase g at the beginning of it, because it's a global. We're not doing that in main.lua with some of the globals we have because they're no real fantastic reason, I guess, because they're all used within, well, they're not globals, technically speaking, actually. They're all locals that are highest level in main.lua, but they're not technically global. You can't access them from other modules. You can only access them from main.lua. So I guess that's maybe the reason. G sounds equals, this is a new table, so each sound needs a string key. So in this case, a laser equals love.audio.new source. This is how you declare an audio file, an audio object. Love.audio.new source sounds/laser.wave. And then I think it takes in a word after that to declare whether it's static or streaming, and then explosion. So static or streaming just means whether or not it will sort of load the audio dynamically into memory when it needs to get used and then sort of free it up. Static means it's always stored in memory. So smaller files, smaller sound files you can keep in memory and it's not a problem. For a game with a lot of music, for example, Super Smash Bros., the new Super Smash Bros. Ultimate has 900 songs, all I assume CD quality. That's a lot if you keep all those in memory at one time. So those you would want to stream from disk. In this case, we're not streaming them. We're just going to keep them static. They're small sounds. They're very few kilobytes. Love.audio.new source sounds explosion.wave static. And then in ship.lua, this is where we actually instantiate the projectiles. So I'm going to say G sounds laser play. And actually, right before I do that, I'm going to call stop on it. And what this does is if the sound's already playing, it stops it and then replays it instantly. And this is to solve the problem that happens because if you try to fire a sound or play a sound in Love 2D and the sound's already playing, it won't re-trigger the sound. It'll just keep playing the sound that was already playing. So you can't like rapidly hit laser and have it go toot, 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 toot. It'll just play it only as fast as the sound itself is going until it ends, and then it'll trigger a new one. But we want it to basically, if the user presses spacebar fast, we want it to trigger every single time. So we're going to call stop and then play, and that will solve that problem. And then in main.lua, when we actually do the collision, we're going to say G sounds explosion stop and G sounds explosion play. Just like that. So this should work. Yep. So pretty easy game, I would say, at this point. We might need to throttle how fast we can shoot the laser. But it works, right? It's pretty cool. The other thing that we need to do, which we haven't done, which we mentioned we would do, is get rid of the projectiles when they're off screen. JP Guy says, gotta go for a while. Hopefully be back before stream ends. Good luck with the Space Invader stuff. Thanks so much, JP. Appreciate you having you on. I'll see you next time. Tune in on Friday for David's stream. He's going to do some Docker stuff. It's going to be super cool. M. Kloppenberg, thanks for the tip. Downloading BFXR now. Awesome. Yes, it's a great sound synthesis program. I love it for simple, like retro style stuff. Sustain. Yep, did all that. Death to them all, says JP Guy. Death to all the aliens. Normally when you hear the word love, think of romantic stuff. Now immediately thinks of love.update. Yeah, I've ruined that idea for a lot of people, I'm sure. All right, awesome. Everyone's thinking that this is super cool. I think it's super cool too. I mean, the sounds really seal the deal, right? Like now it actually feels like we're playing a game. It's not just a little weird demo-y thing. We're actually getting somewhere with it. So that's that. Let's also take care of the projectiles being at the top of the screen. So we can say if projectile dot y is less than or equal to 0 minus projectile, or as we can just say negative projectile length, then projectile p key is equal to nil. And then we want this to be in an else. This for loop then needs to be in an else statement, because if we do this, this projectile collide function will break because that's now a nil object, right? Is that true? I think the object will still exist. We still have a reference to the object itself. So I don't think that's necessarily true, but we should still put it into an else, just for good measure. Because logically, we don't want to check to see if it's beyond the edge of the screen. We don't need to check to see if it's colliding with an alien. It's impossible. It's beyond the view. So we'll do that. So now we can demonstrate that this works if I, in my love.draw, if I say love.graphics.print projectiles toString length of projectiles. So this should print, yeah, projectiles 0, right, up at the very top. Yep, see, they're all set to 0. So we have no projectiles left. They're all getting set to nil. Pretty cool. And it looks like it rendered. It renders it. I think it takes it a second to unload. Like the reference is nil, but for some reason it takes it like half a second to actually update that number. So it stays. It'll like instantly go to 0, everything. But it works. It's good. We are freeing our memory as we use it. So we don't need to worry anymore about sort of having a ridiculously long update loop or running out of memory. Those aren't concerns anymore. We can check if the projectile is nil or now in the loop before shooting. Well, we're not going to. Oh yeah, I see what you mean. Yeah, we could do that. It's probably unnecessary and more code than just doing an else statement, though, to be honest. So that's OK. Probably slightly more efficient, too. Oh, wait. Yeah. Yeah, slightly more efficient, because it's going to iterate through every alien if we did that. So we're just saving some cycles. It's not a huge optimization, but it saves us minimally 55 if statements, if not more than that, if not more logic than that. Maybe it's more complicated than that. So turns that into just an else. So it's pretty cool. Oh, we have a special guest today with us here. Who do we have on stream? You might be cut off. You might need to crouch a little bit there. Hey.
Nice to see everyone.
Is this the first time I've seen you since
2018? Yeah.
Yeah, that's pretty. I didn't realize that actually. Yeah.
These streams are like a tour of my childhood, it seems.
Oh yeah. Did you want to play a little bit of crappy?
Yeah. How far along are we now?
We got projectiles, and you can use the arrow keys and spacebar to shoot some aliens if you want.
All right. Hey, that's a lot of diverse enemies up there.
Yeah, we have it all. They're set to a random index on a sprite sheet. We just implemented getting rid of projectiles when they're off screen, so now the memory gets freed. That was the most recent step.
I still remember that sound. There's a very prototypical laser sound.
Yeah, we used, if you remember from the games course, the BFXR tool, which used to generate sound. You did. You started a new course today, right?
We did. We're teaching a new course on computer science and the law at Harvard's Law School, in fact.
How'd it go?
Yeah, good. Doug Lloyd will be co-teaching too, so he takes over later this week. So a few more lectures up this week.
Nice. And then you're coming in on Friday.
Oh, yeah. No surprise this time, though. What game are we playing on Friday?
Oh, it's called Docker.
Oh, yeah. So we actually use Docker, which is a containerization technology, which is similar in spirit to virtual machines, if you're familiar. So we're looking forward to talking about how those works and how they drive all of CS50's infrastructure and increasingly a lot of cloud-based services as well.
Nice. I'm excited to learn a few things about Docker as well.
Cool. All right. Well, I don't want to take away from the game. Good to see everyone. See you back in the chat, and thanks for tuning in.
Cool. Thanks for popping by. Appreciate it. All right. So we did the freeing of the memory when the projectiles go off screen. So the next thing that we should probably take a look at maybe is have the ships fire back at us. Because currently we can fire at the projectiles, but it's a one-sided battle. The projectiles, rather the aliens, cannot actually give us any challenge. Eventually they will come down towards the player and theoretically collide with us. Well, they will collide with us, certainly. But yeah, actually having an adversary fire at us is probably worth implementing. So why don't we take a look at that? So in the alien class, this is probably where we want that to happen. Amine Benamor, thank you very much for following. And actually, now that I think about it, probably not the alien class, because only a specific subset of aliens are going to want to be able to fire at the player. Do not give them weapons. This is how it starts, says Asley. Yeah, no. Unfortunately, for the sake of having an interesting enough game to at least give us a challenge, as what Bavik is just mentioning now, we probably want to make this a bidirectional game. So my initial thought was do it in the alien class, but that's not going to work necessarily well because we need to have access to all the aliens. We need that access to that information because we need to figure out which aliens are at the bottom row. And the reason we need to do that is because if we look at the game and we see the aliens moving, if we allow every alien to fire and the aliens all, and the projectiles will sort of indiscriminately collide with other aliens or the player's ship, as you can imagine, all the aliens that are above the other ones will kill the aliens below them. And this will therefore leave only this top layer of aliens once a couple, depending on how fast the shooting interval is, once that has passed. So what we want to do, exactly, Bavik Knight saying the bottom row aliens only, otherwise the aliens will kill themselves. That's correct. So we only want the bottom row to shoot. However, we want the bottom row to shoot, and that includes aliens that we defeat from the bottom rows up. So if, for example, if we defeat an alien there, the alien above it should therefore be able to shoot at us now. And same thing if we do it again, then the alien in the third row now should be able to shoot at us, and so forth. So we need to figure out, I guess we could sort of tweak the aliens that can fire based on the aliens above them. I guess which aliens we defeat, we can, whenever we defeat an alien, we can then trigger some code that gives the alien above it the ability to fire. That's probably the easiest way to do it, honestly, is to give each alien a flag. So the alien, I guess we can just do it in entity, because ship and alien can fire. So self can fire is false. We don't want every alien to be able to fire necessarily. Colton is trying to build Skynet. He is one of them. I can neither confirm nor deny such claims, such accusations. I'm going to, in my ship, not my ship class, in main.lua, where the ship gets instantiated, I'm first going to let the ship fire. Ship can fire is true. This should be true. And the aliens are all going to be, by default, not able to fire. They're going to be set to can fire is equal to false. So let's go ahead and give the bottom row of aliens the ability to fire. So we generated all the rows and columns. And then I'm going to say if y is equal to aliens tall, then so this is, OK. So what I'm going to do is I'm going to say local alien is equal to this bit of code here. So what I've done is I've taken that constructor out of the table.insert function so that we can store a reference to it here. So local alien equals alien at xy math.random256 for the random frame. And then I'm going to say if y is equal to aliens tall, which means if we're at the bottom row, then I'm going to say alien can fire is equal to true. Right? So this will only give aliens at y level 5 the ability to fire. And then in our update, so the, do I do this in update? I guess I can in alien here. Yeah, I can say if I want it to be on a timer, and I want to give each alien a random interval of time that it will fire. Because I want it to be kind of random. I don't want them to be on a consistent timer, because if they are, they'll all fire at the exact same time, and it'll be kind of like a blanket of fire, and it'll be weird. It won't be unpredictable. It won't be fun. So we need to also, each alien needs to have a reference to its own firing interval, right? So it needs to randomly choose a length of time. It'll wait to fire and then fire. And then when it fires, it needs to reset the interval to some other random value. And we can set it between maybe 1 and 3 seconds. Or no, because that'd be pretty fast. Maybe 1 and 7 seconds. Yeah, we'll do it between 1 and 7 seconds. 1 in 10 seconds. Yeah, 1 in 10 seconds. This is all game design, game balancing, that sort of thing. Again, up to taste more than anything else. You want to tweak values, mess with them, figure out what works. So we're going to say, what makes the most sense here? Do we put it in here? Because if we do that, we need to create a new constructor. Just brainstorming for a second, figuring out what makes the most sense. We can check if the alien has another alien in front. Yeah, we could do that, but that's going to be a little bit less, I think, not as clean of a solution as I want to look for. I mean, it works. That solution would work fine, I think. We can set it so that if there are fewer aliens, they shoot rapidly. When more aliens, they shoot at a slower pace, as Bevik Knight. That's not a bad idea. That's pretty cool, interesting sort of game design idea. Certainly would work. Certainly would be good. Just trying to figure out how to structure this in my head before we actually code. So we do the aliens that can fire need a timer, a fire timer. Fire timer is going to get a random value between 1 and 10, and that's the number of seconds. Each one will therefore need a timer itself. So an interval and a timer. The interval will be the amount of time to wait for it to fire. The timer itself will be the amount of time in delta time in seconds that have elapsed to wait for that interval to have passed. We'll then fire. We'll reset the timer, create a random new interval. So yeah, we have the pieces. So the best place to, I mean, dynamically, we could just do it in main.lua. We could just say, alien.timer. Everything needs a timer. Every alien is going to need a timer so that we can update it. Well, it will have a timer. Okay, so alien.timer is equal to 0. Fire timer. Should be called fire timer. Try to be a little bit more verbose when you can. And then fire interval. And that's going to be math.random10. So this is the random length of time that will pass. Aliens at the back have less pause, and aliens at the front have more pause to shoot. Yeah, that's a good idea, Bevik. Not bad. I would recommend implementing something like that for sure. Try it out. That's a good example of a mechanic, like an actual mechanic to influence the gameplay, the difficulty of the game. So fire timer is 0. Fire interval is equal to math.random10. So what we can then do is say in our update, tick aliens. It could go in tick aliens too. I'll write it in here, and then maybe we'll make it a separate function. So for underscore alien in pairs aliens, do, and we're going to say if if not alien dot invisible, because the alien can't shoot if it's invisible. If self dot can fire, sorry, not self. If alien dot can fire, right? If it can fire, then that means that it will have a fire timer and a fire interval. So we'll say alien dot fire timer equals alien dot fire timer plus delta time if alien dot fire timer is greater than or equal to alien dot fire interval. So this means that amount of time has passed that's the same or greater than the actual interval that we're waiting for this particular alien. It's going to be random for each alien. So if this alien is set to fire after 5 seconds and 5 seconds have elapsed, then I'm going to set alien.fire timer equal to alien.fire timer minus alien.fire interval, so set to 0 or roughly 0. And then we're going to spawn a projectile, and it's going to go down. So this is kind of what we did before. Table.insert into projectiles, a new projectile, which gets x, which is going to get alien.x and alien.y plus alien.height. And then it's going to be set to down. So this projectile is going to move downwards. It's not going to move upwards, right? So let's try this. Oh, hey. Whoa. Nice. OK. So some of them are firing in tandem because it's not a floating point value. It's an integer. So the random number. Oh, we forgot to change the. We forgot to change this to another random value. So alien.fire interval is equal to math.random 10. Right. Aliens can't shoot when they're invisible. This is in line with Star Trek. As far as I recall, the Romulan spaceships couldn't fire while they had their cloaking devices on. That's interesting. I've not watched much Star Trek, but that sounds very apt for this particular example. But the aliens are firing. Now, the only thing is they're not shooting at us. So I guess I do want the alien to also do the sound effect for firing. So G sounds laser stop G sounds laser play. Now I kind of almost want to have a different sound effect. It's kind of cool because it's creating like these obstacle courses that I have to fly through. Whoa, like that. Oh, it went right through me. There's no collision for the ship yet, actually, so it's not doing anything. So it can just go straight through me. I forgot. I like instinctively wanted to dodge it. Yeah, the sound's not that bad because it stops every one when it fires. Different sound effect would be better, says Andre. We can do that. Different sound effects. So let's do some lasers. Not that one. That sounds obnoxious. Even more obnoxious. That's not bad. I kind of like that. I'll do that one. Alien laser. Different alien projectile color as well. That makes it a little bit more complicated because then we have to add that as a field onto the class. Maybe we can make that an optional feature at the end if we have time. For simplicity, we're going to keep them the same color just for now. Dependencies. It's a good idea, though. I don't think that it's not a good idea. Just I don't think we have the time. But no, it's an awesome idea. I totally agree. Alien laser equals love dot audio dot new source sounds alien laser dot wave static. Alien laser dot wave does not exist. What did I call it? Called it alien laser dot wave. Oh, sans. Nope, it needs to be sounds. Okay. Oh, now we have to actually call the right sound effect. So in here, it's alien laser. Yeah, I kind of like it. It's a little deeper, a little bit deeper than the regular spaceship. So it kind of has a more, even like a weird, very subtle, sinister difference. So I kind of like it. It's pretty cool. Yeah, that's great. We'll do it. Ship it. Now, the projectiles should collide with the ship as well. So what we should probably do is updating it if it's less than projectile length, or projectile dot y is greater than virtual height. Remember, because these are the projectiles that go below the edge of the screen. We have to keep track of this as well. Then set it to nil. We were only checking above the top edge of the screen. We also need to check the bottom edge. And we need to also check to see if it collides with the ship. So we can say if we can shortcut this too. Do we want to do that? No, we'll just say if projectile collides with the ship, ship.invisible is equal to true. So because ship inherits from entity, this should result in the ship dying. Yep, perfect. So I'm still moving the ship around. I can still move it around. But it is not visible. And I want an explosion sound to play. I want a different explosion sound to play than when the ships die, though. I want a more dramatic sound, I think. So let's try it here. Oh, that one's all right. It's not quite long enough, maybe. That one's very dramatic, but it's kind of appropriate. Cool. We'll do that one, just for the drama. Death.wave. Let's go over here. We got to go into dependencies. We got to add death.wave. Audio dot new source sounds death.wave static. Cool. And then here, instead of explosion, we want death. Lots of positive words. All right, let's try and die. There we go. Very dramatic death sound, and the player does die. We do not go to a different screen, unfortunately. That is not yet implemented, but that's probably the next step, honestly. We've implemented movement. We've implemented the ship's firing. We've implemented death on the player's side. There's no score yet. Score is important. We probably want score. The title screen, probably important. Yeah, that's probably it for now. The next part is going to be the largest part, the more complicated one, I suppose. So let's do that. So the title screen. Well, the state machine class first. I'm going to create a new folder called states within source, and then I'm going to create a new file in source called statemachine.lua. And a state machine is a oh, it's been a blast thus far. Have fun with the rest of M. Kloppenberg. We'll have to watch the part later on. Thanks so much for joining M. Kloppenberg. Glad to have you with us. Hope you enjoy. Be sure to tune in on Friday for David's stream. It's going to be super awesome. The state machine class is a state machine is essentially a finite representation of what the state of something is, whether something is, it can only be in one state at a given time, and going back and forth between states occurs during certain transition criteria, right? So you have a title screen. When your game is in the title screen, it's in a state of being in the title screen. It's not, you're not playing the game, you're not at a game over. It can only be in one state at a time. You can't be at the title screen and the game over screen at the same time. That doesn't really make sense. You could maybe make a game that tells you you lost, but is also sort of the game over, but it's technically still going to be a different state, more than likely. A state machine is what allows you to transition between the states, the different states of your game. The state machine is just kind of like a thing that points at whatever state's currently active and updates it, checks for the transitions, and then transitions when it needs to do so, and keeps track of that. The actual states themselves are how we modularize our game, and we can then implement the title screen separate from the play state, separate from the game over state, etc. So the state machine class, first of all, it is a class. So like we did before, I'm going to create it as a class. The state machine has an update and a render function. Just like a lot of the other stuff that we did, we're going to call this from main. It also has a change function, which will allow us to put it into a particular state. And we want to actually be able to create it. So it takes in a states table, which we are going to store all of our states in. So when we call change state, what we want to do is essentially say self.currentState. We're always going to have a current state. And this state machine can apply to creatures in your game. It can apply to the game state itself. You can basically make a state machine for anything that changes state and that you want to modularize the state of or encapsulate into a discrete file or module. You can use a state machine for it. It's pretty flexible, and typically use it for creatures in the game or game states most often, but you could find multiple uses for it. The state machine will always have a reference to whatever the current state is as its current state field. And that changes depending on when we call change and so forth. So I'm going to say self.currentState exit. So every state is going to have an exit function and an enter function. The exit and enter functions function as the transition, sort of an abstraction of the transition of a state from one state to another state. When you transition from one state to another, you call exit on the state that you're in. So it'll clean up whatever it needs to do other stuff. And then it will call enter on the state that it's transitioning to. And then it will set the current state to that state. And so the enter basically lets you clean up stuff in the state that you're currently in if you need to do so, free memory, do whatever you got to do, and then call some initialization code in your new state with the enter function. And enter usually takes params as well. So that'll be this. It takes in a params as a second field of that function. And then I can say self.currentState is equal to self.states state. And then oddly, I do call it as a function, which we'll see here in a second as to why we do that. You don't have to necessarily do it that way, but it's a nice, clean way to do it when you have a game that uses like fresh states every time you do a state transition. And then I'm going to say current state, enter params. Self.states is equal to states. Self.currentState update. And self.currentState render. So we have a state machine class that will take a dictionary, take a map, take a table of states, and they're actually going to be in the form of anonymous functions. And we'll see that. That is why we call this here, this parentheses here, like where you're doing a function call, because each of the self.states is actually a function. It's actually a function object. Mirkist, thank you very much for following. So if I go to main.lua here, first of all, go to dependencies.lua and require source state machine, like so. And in the love.load, this is where I like to initialize the state machine. I'll usually do it after the all the setup stuff. And back for another half hour or so, says JP Guy. Thanks for joining again. Just doing some state machine stuff now, so a little bit more meaty, so to speak. It's a simple class, but a very flexible, very useful class. What we're going to do is I'm going to create a G state machine. Now this G state machine is global because we might want to change our state from within other states. Well, we are from outside of main.lua. We are going to change it from within other states. Each state of our game is going to be able to transition to other states. So we need it to be, the state machine itself needs to be global. So I'm going to do this here. And I'm going to say title is equal to an anonymous function that returns a title state object, which we have not seen yet. Play is going to be equal to a function that returns a play state, which we also have not seen yet. And game over is equal to a function that returns a game over state, which we also have not seen yet. And I'm going to change our state to the title state. Takes no parameters. And we want to make sure that if self.currentState, then we want to basically put this in an if statement, because if we're starting the very beginning of the game and we don't have a current state enabled, then this will not work, because self.currentState will be equal to nil, and we can't call exit on nil. It has to be something that has an exit method attached to it, which is every state. Every state needs to have enter and exit associated with it. It's part of the interface. That's how we can get this to work. It assumes that any state that we implement will have that interface. This is kind of like an interface, as for what Bhavik mentioned earlier. But again, this is all dynamic. Nothing's going to enforce that these functions exist. It's up to you to enforce that. So I'm going to go into states here. I create a new file, and I'm going to call this base state. Not the most useful comment blocks of all time, but better than nothing, I suppose, arguably. Base state is going to be the state from which every other state inherits. And the reason that we want this to exist, we wouldn't normally need this, but this is to prevent us from having to write empty enter and exit methods for our future states. Because not every state needs an enter and an exit method, but our state machine assumes they exist. And because it assumes they exist, we want to basically make sure every state has this interface. It adopts this interface. And so we get this through inheritance. So base state is to be equal to a class. And all base state is a bunch of empty methods. Base state update, render, enter, which takes parameters, and exit. So this is all that base state is, just an empty class. Oh, not completely empty class, but a class with 5 empty methods. An init, update, render, enter, and exit. All functions that the state machine assumes exists on each state that it works with. So now what we can do is I can say new file in states. I can call this title state. And title state is going to be equal to a class which includes includes equals base state. Right? And so now this is essentially the same thing as copying over these 5 methods into title state for free. So if we just saved it like this, titles class is essentially the same thing as title state. Sorry, this should be title state, not title class. Title state will be the same thing as base state, essentially. They have the same methods. We don't want that to be the case, though. We want title state to actually have some behavior. So what I'm going to say is any function now that I define that is the same name as these will just it'll just override that. It'll just replace it with our own version while keeping the other ones that we inherit from base state, which is super useful. So what we can say is title state, and then this will be update and render. We only need these 2 for now, just to demonstrate how it works. So I'm going to say love.graphics.print Space Invaders. This is the title screen. Actually, this is going to be printf. Title screen, right? So this is going to be Space Invaders. It's going to start at 0. It's going to be roughly in the middle of the screen. Virtual height divided by 2 minus, I don't remember how tall the font is. I'm going to assume 16, so I'm going to have -8. It's going to use the width of the screen as its wrap amount, and I'm going to center it. Oh, sorry, this should be in the draw function. And up here in the update function, I'm going to say if love.keyboard.wasPressed enter, or love.keyboard.wasPressed return. Then I'm going to I'm going to bit of a brain fart. G-state machine change to play. No parameters. So maybe you see what's happening here. It'll be clear shortly if not. This is just a title screen that's going to say Space Invaders in the middle of the screen, and it's going to check for input. When we press enter or return, return taking into consideration MacBooks, which by default the enter key is return, it's going to use that G-state machine we declared in main.lua and transition to our play state, a state that we defined as play. And again, the states are all here: title, play, and game over. Those are the string keys, and they map to anonymous functions. These anonymous functions are being stored in our state machine in self.states. So self.states is just a reference to this table here. That's what this curly bracket syntax is. Remember, you can instantiate a class with its name and curly brackets if it just takes in a dictionary or table or map, however you want to look at it. And these are anonymous functions that are stored there assigned to these keys. So key value, the values are function objects. Those function objects will be called here, right? And remember, they're all they do is they just return a state, a title state, a play state, and a game over state, a fresh state, completely blank, which we set to self.currentState on line 13 here by saying self.states at state, remember, change to state. And then we call these curly brackets. That'll actually call the function object. It'll execute that function's code, and the function's return value is that state object, depending on whether it's a play state, a title state, or a game over state, and therefore assign it to current state. So then we have a reference to that state object, a brand new clean state object. Metal Eagle says, hello, CS50 TV. Hello, Metal Eagle. Glad to have you with us. Happy New Year. So that's how the state machine is working. That's how it's getting the state object, and it's keeping track of whatever state is currently active. We still have a few pieces left to implement, though. Why don't we go ahead into while we're already implementing the different states, the title screen, let's add a play state. The play state is essentially going to be all the stuff that we implemented in main.lua already. Play state equals class, includes equals base state. And so what this is going to do is all of this stuff here, right? This is all going to be set into the init function of the state. Play state. Right, so that's what this does. So self dot, we're using self now. So we're no longer having these pseudo global variables that are at the parent level of our main.lua. Now they're actual member variables, member fields of the object itself, these new state objects. We've essentially taken all of our logic. We've found a way to take the game logic itself and put that into a class. And so now we can modularize how our game flow works and not put every bit of important logic into main.lua. So it's super nice. And that includes also these variables up here, right? We don't need these in main.lua. Those can be in the play state, just like that. And they're no longer local, right? So boom, 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 boom. There's self dot. And now these, the local, the ASLI and BAVIC variables were just kind of stored temporarily. They aren't really ever referenced later on. So we can keep those as locals. We can keep the ship index as local. We're reusing it here, and we're putting that into self.ship, which is the actual ship variable that we're going to use consistently throughout the rest of the course. Oh, it's JP Gay's birthday. Happy belated birthday, JP. Did not know as well. I apologize if they mentioned it before. I did not know. December 17th. Nice. Happy birthday. So now notice that self.projectiles, self.aliens, self.ship is not necessary here because we assign it here. Yeah, we declared it in advance as a local so that we, because we wanted to reference it later on, and you do that. If you want a local variable that you reference from within a nested scope, you need to define it above that function, which is why we did it before. We don't need to do that anymore because we can just call self.ship here and assign it. So super straightforward, save a line of code, actually. All of these we can keep in main.lua. We can keep push. We can keep all the initialization stuff. We can keep the state machine itself being initialized. All of this stuff, though, this is all actually in the, this is all update code for our play state. So copy that, bring it over here to our update function. So this is cool. So remember, every time we have a reference to ship, it's no longer just a reference to ship or projectiles. We actually have to reference it as self.ship and self.projectiles. So that's important that we keep track of that. You make sure that I'm not missing any of those. OK. And tick aliens, remember, that was a function that was in main.lua. We no longer have access to that from within here. So what we want to do is we want to take tick aliens, probably out, and take that out of main. So again, saving space in main, allocating it to a different module. Can I just copy it here, right? Yeah. OK. And self.aliens. Self.aliens. Cool. And alien movement timer, that's a self as well, right? Yep. So we want to set alien movement timer. Boom, boom. Self.alien movement timer. And alien direction as well. Yep. Alien direction, that also gets adjusted. So alien direction becomes self.alien direction. Whoops. Boom, boom. Self.alien direction. Perfect. So that should be good. That looks good to me. So our main.lua is now 68 lines of code, so we've actually reduced it quite a bit. The draw as well, we can get rid of that, right? So we can do this, get rid of this, go over here to make a draw function. Render, I should say. And this should also be set to play state tick aliens. And this will be self tick aliens. So here we do this. So pairs self.projectiles, self.aliens, self.ship. So everything is kind of coming into plan here. Code looks very good and modularized now. Yep. Thank you. Watch the video about state machine 600s. Of course, someone has mentioned it before. Yeah, super useful construct in game programming. Ubiquitous. Very useful. Very helpful. OK. We're going to keep if key is equal to escape in our actual main.lua, so it's accessible from within every single game state. Now, the missing ingredient is we actually have to call g state machine render and g state machine update, right? Because if we don't do that, then all that code that we put into play state is just kind of lost in space. It still needs to be triggered. And we do that from within the main.lua using the state machine object that we declared earlier and that we initialized. So assuming that I did everything right, and actually I know right now that I did not actually require the states themselves. Very important that you do this. Title state. And because I have a reference to it, I am going to require a game over state and just add it really fast. Game over state.lua. Game over state class. Oh, not function game over state. Game over state is equal to class includes equals base state. Cool. Now, assuming that everything is in place, this should at least give us a title screen. And as soon as we hit the title screen and we press enter or return, we should get transitioned to the sort of the game as we saw it before. So let's take a look. Cool. Pretty nice. We see we have the Space Invaders text in the middle. Because remember, we're defaulting to the title screen, the title state. So it's starting right off in the middle of the screen. We press enter. OK, so it's not completely perfect. Play state line 33, bad argument to insert. OK, play state line 33. Let's see what that looks like. Ah, aliens. It needs to be self.aliens. Let's try that again. Bad argument to pairs, play state 66. Probably the same bug. Yep, self.aliens. And play state 112. Yep, self.aliens. OK, boom, 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 boom. Remember, aliens by itself is no longer meaningful. It needs to be self.aliens because it's within the play state. So now, OK, 78. Still have a few that we missed, which is OK. Self.projectiles, yep. Hopefully we haven't missed any other ones. Let's see. OK. Yep, right here, self.projectiles, self.projectiles. OK, so hopefully that works. Once again, 16. Ah, man. Wait, what did I miss there? What was that? Projectile line 16. OK. So projectile line 16. OK, takes in an entity, which gets an x, y, width, and a height. So where are we referencing that from? Let's see if we have a stack trace here. OK, that's from line play state 56. OK, play state 56. Ah, this needs to be self.ship, not ship. OK, and this needs to be self.ship as well. A lot of these little things you got to tweak. If you start this off from the beginning in a state, what was the key code to press when changing two of the same names at once? Oh, if you highlight something, you can press Command D or Control D, and that will highlight the next thing of the same name in VS Code, and in a lot of other text editors like Atom too. All right, is this working? Come on. Okay, that looks pretty good. Let's make sure that I can shoot other ships too. Okay, cool. One thing that we didn't implement, actually, which is important, is that the ships above the ships that die on the bottom row haven't been given the ability to fire, so we need to also do that. But yeah, we've modularized everything. Everything is cool. We have two different states now. We have a title state and a play state, and the last one will be a game over state when we die. So as soon as we die, we should just do a change to the game over state, which we can very simply just kind of copy over the title state stuff here, making sure to rename them to game over state. And then we want to set this to title, and then game over like that, which won't do anything because we're not actually transitioning to it yet. So from within play state, what we want to do is when we die, we want to gstate machine change to game over. Is that how I named it? Let me make sure. Yep, perfect. So now when we die, we should go to a game over. Let's try it. Awesome. So we have a game over. If I press enter, we go back to the title screen. If I press enter again, back to a brand new game. Now do the ships regenerate? Okay, so the first one's a green one, and then yep. So the ships themselves also regenerate. Sorry if that was a lot of sound at once. Metal Eagle says, why do you have call stop before play? So we mentioned this before. What it does is if you're triggering in Love2D a sound effect, and you trigger it fast before it's finished playing, Love2D will not refire it. It will let the sound effect keep playing until it's finished. And so if you want to have a rapid fire laser, for example, you'll kind of just be stuck waiting about the waiting for the first sound effect to finish, and it'll kind of be like a weird sort of sometimes it'll fire, sometimes it won't kind of sound. So if you stop the sound effect and then play it immediately afterwards, you will be able to re-trigger it instantly. So you'll get the effect of rapidly triggering that sound effect over and over again. So, good question. You weren't thinking about separating the entity class, and with modularity, look how far we've come with state machine. Yes, yes, says Bavik. It's a good point. Always try to modularize stuff as best as you can. I mean, I'm sure we could do a better job of modularizing what we have now. It's fairly well structured, but you can almost always get better at organizing stuff. Just kind of break, if you see really large functions, it's a good heuristic is just kind of break those up, make smaller functions. Separating the states is very good for game development, that sort of thing. Yeah, it's a good practice. Always try to make the most elegant code that you can. It's difficult if you're in a rush and you have deadlines to meet and stuff. Sometimes you can't do it, but as best as you can, as much as is realistic for your hobby projects or whatnot, it's good practice, if anything. The other thing that we were going to do is we were going to make sure that aliens could still fire at us from the upper rows when the lower rows are cleared out, and we also want a score. And we want to display the score when we get a game over. So what we can do is, and also we could, we would also want to trigger a new level each time we clear out the map. I'm not sure if we'll have time to do that, but we could certainly talk about it. But for now, let's do the aliens being able to fire when the lower aliens are cleared out. So what we can do is, where is the code located at? Balthazar Brat, thank you so much for following. Appreciate it. In play state. So in play state where we actually check each projectile against each alien, what we're going to want to do there is when we do collide with an alien, which is what we do here, we trigger the code for clearing it out. We want to give the alien above it the ability to fire, give it an interval, that sort of thing. So what we can do is A key will be the number, the index of the alien, right? Every time. That's what we have it set to here. That's why we need to declare it. So we're going to say if A key is greater than 11, and the reason that we're setting it greater than 11, and what we should actually do is use a constant. So in this case, alien's wide, right? What this will give us is true if it's anything greater than 11, which is the length of an individual alien row. So any alien beyond the top row, right? So if it's the case that that alien is below the top row, then we want to say aliens at A key minus aliens wide dot can fire is equal to true. And we're going to say, we have to do the same thing that we do when we basically figure out if the y level is aliens tall when we initialize the aliens. So we're going to say can fire is equal to true, fire timer to 0, and fire interval to math.random 10, right? So fire timer equal to 0, and fire interval math.random 10. That should work. Let's try it out. So I'm going to clear out this alien. Whoops. Playstate 55. I forgot to do self.aliens for all of these. Let's make sure to do that. OK. Clear that alien out. So pay attention to that. OK, so he killed the other alien. So that was that's an unfortunate bug. Whoops. Let's try that again. So the reason that's doing that is because the movement is fast. It's too fast. So we can maybe tweak that. So if we set constants to the alien movement interval to 0.75. OK, so it's still killing the aliens below it. So how did I fix this before? I'm trying to remember. I solved this problem once before. The simple thing to do are they spawning at... They're not spawning in the middle of the ship, are they? No, they're not. That is a bug. So what we want to do excuse me. Yeah, the projectile is spawning right at the alien X. We don't want that to happen. We want it to spawn at alien size divided by 2. Alien X plus alien size divided by 2. That should fix it. That should fix it. Now it's right in the middle. There we go. Perfect. So it was spawning right at the X, right at the edge of the alien, and so it was instantly colliding with the alien right below it. If there was an alien right below it, so you don't want that. You want the lasers to spawn right in the middle of the alien. So we fixed that problem. Let's try and clear out a bunch. See what it looks like. Whoa. They can still sort of kill each other. Yeah, because they move in such a way that the movement itself might be slightly off of when the projectiles themselves move. So I think what we should do is set the movement interval to 0.7 and not 0.75, so it's not in between a second. Because all the lasers will always fire at a second, I think. Oh, I guess not, because when we kill the alien, it changes the... Oh, whoa, that was weird. I got an alien to die above another alien, which is probably because I shot a projectile and it moved right into it. That's pretty cool. So yeah, lots of fun stuff. To do, features would be ask a player name, score, highest score with the player name, levels, etc. If the alien should check whether any alien is in front of it or not before shooting. Yeah, that would be one way to solve the problem a little bit more appropriately. The problem isn't that there's an alien in front of it. The problem is that there's it moves into it on the frame after it's shot the projectile. So anticipating that is a little bit trickier. I could just make all the projectiles always spawn at the lowest Y level, but that's not as convincing looking. We won't spend too much time fine-tuning that, I don't think. We'll kind of consider it a feature for now, just for the sake of time. I think if we had like more time, we'd actually implement perfect, I guess, laser firing from the aliens. It's pretty good though. It works pretty well. Andre says, you could do what the other original game did. With game creation, I found some glitches that you did not initially intend to be a cool and unexpected feature. Yeah, games are so crazy a lot of the time that stuff that you try out and mess up ends up actually being interesting, and demos you create end up being fun. It's pretty cool. And then Andre said you could do what the original game did, but I'm not sure what that is. Andre, if you wouldn't mind elaborating, that'd be awesome. Aliens, lasers would be ignored by aliens. Oh, yeah, we could do that too. I could just, yeah. I could say if projectile is down and it collides with an alien, do that. It's not super important at this point, I think. We'll let it exist as it is. It works well enough for the demo. It's probably somewhat fairly easy to fix. And I encourage, actually, if you're following along, to try to fix it, because that'd be cool. Let's implement a score mechanic in the play state. And then let's feed that into our game over state. So let's go ahead and set a score to, well, here I'm going to set the score to 0. And in the render function, I'm going to draw the score after the ship. So love.graphics.print score toString self.score, just like that. So that'll print a score in our play state, which it does, very top left. Pretty cool. It's not going to change though. We don't get a score anytime we kill an alien, but that's easy. All we have to do is go to our update function, and whenever we collide with an alien, which is here, say self.score equals self.score plus 100. Pretty easy, right? And then I die. But we're not feeding the score to our game over screen, so we can't see what our score actually was. So we should probably do that. So I'm going to, in our, where we call game over, which is, where is that? That is, it's right here. So game over, remember the change function can take parameters. So what we're going to do is we can say, we're going to pass in an anonymous table, and I'm going to say score is equal to self.score. And And what this is going to do is it's going to pass this table to the game over state with a key of score that equals the score as it is right now, self.score. So in game over, I'm going to game over state, enter params. Self.score is equal to params.score. So remember, that table is going to get passed into in our state machine. This is what params is. It's going to be fed into current state enter, which is the new state that we're getting. And we just pass in that params as a table. So then game over state. Here we have params. We have access to it. Self.score is equal to params.score. And then here I can just say your score toString self.score. So let's go ahead and get some points. Whoa, that's horrible because all I did was copy and paste it. So what I'm going to do is I'm going to say virtual height divided by 2 plus 32, I think. Try that. Okay, pretty good. Not bad. Not as much as I wanted it to be. Let's do plus 8. That's pretty nice. We can move it up a little bit, probably to be more vertically centered. We won't worry too much about that kind of detail. That's something that you can just solve by messing around with it. But yeah, that's pretty much it. I guess one more message we could add to the title state would be the press enter. Just like that. There we go, Space Invaders. Press enter to play. When we press enter, we play, we do this. Do that. Game over, by score of 900. Space Invaders, press enter to play. Bevignite says, what does the ... do in front of toString? I forgot. ... is the string concatenation operator. So what that does is it will just add two strings together and just add one directly onto the end of the other one. So in some languages, plus function, like Python, you can just use plus. ToString just means convert a non-string value, a numerical value, to a string, and we're using ... to concatenate your score, and then that string converted value, just adding them together. All right, that was pretty much all I aimed to complete for today's stream. I do want to stick around for any questions if people have some before we adjourn. In case I went too fast over something, I would like to do that. Maybe receive any ideas or suggestions for future streams. That would be awesome as well. I know that Asley did say she wanted a typing game, so I have been thinking about that. We'll probably do something like that. I might do Hangman first before I do the typing game. We can use Hangman, build Hangman, and then use some of that code to develop the typing game, which would be cool. And we could talk about what kind of typing game, just a generic typing game. I've never made a typing test before. I mean, a simple typing game would be pretty easy. Just get the words correct, I suppose. But yeah, as it says, yes, I'm dying for the typing game. Hangman would also be great. That's also sort of a typing game. I did debug it. Oh, one thing that we do want to do is push this to GitHub, right? ls, where are we at? This is in Pong. So out of there, into streams, Space Invaders, git status, okay. Final stream version, cool. So now, as of right this second, the code that we did today plus the code that we did last stream is now on GitHub. So if you want to clone it, mess with it, try and add some new stuff to it, definitely do so. Definitely try to add new features. It's a very good exercise. Maybe use it to create your own game in the future if you want to. We have a full, it's pretty much a full proof of concept Space Invaders. Doesn't have levels, doesn't have a lot of bells and whistles, but it will help you if you want to start building a space shooter of some kind, certainly. Did a Hangman game in 6001, says Bavik Knight, for a P-set. There was a typing game where you got points as you typed correctly, says Astley. Interesting. Couldn't finish the story yet. I'll share it here when I finish it. As are you building an adventure game? I don't remember offhand if we talked about this on a prior stream. I apologize. Any questions at all about the code today or about anything? Anybody have anything they want to chat about for a couple minutes? We have a few minutes left here. Oh, text adventure in Unity. Ah, got it. Okay, nice. There is a Udemy course that uses that teaches how to do something like that. I'm not sure if you're using that, going through that Udemy course by Ben Tristram, I believe. It's a good course. Not about the code because I was late. How was your holiday? Says Astley. Holiday was great. So I was in California. I spent a lot of time with my family. It was super cool. Played games with my dad and my brother and my friends. Played some of the new Super Smash Brothers, which is super fun. Super good game. Like I mentioned it earlier, 900 or something like that, 850 or 900 songs in that game. Insane. Yeah, how about your holiday? And anybody else in the stream, what did we do over our holidays? Certainly the weather was a little warmer over there than it is here now. It's in the 20s today. It's a little chilly. And again, more ideas for games, much welcomed. I personally want to start getting a little bit more into modern web dev this year a little bit. So if folks are open to more hands-on building of websites using React and other tools, that's something that I think I might want to do and learn. So I wouldn't mind doing it on stream if people are interested in that. I think probably more people care about web dev than they do about games. So I'm not sure, but let me know. Definitely that's what I'm using. It's awesome. I moved past the text adventure harder things, but I'm a sucker for writing, so I'm working on it. Wow, 900 songs. That sounds like a nice holiday. Yeah, that's a crazy game. And yeah, it's a good course. Hopefully you can make it through. I would definitely stick through it. Ben has a great teaching style. I'm a big fan of his course. As I said, care more about games. I personally think I care a little bit more about games too, but I'd like to get good at web dev. It'd be cool. I think it'd be fun. It'd be good stuff. Yeah, good stuff. We made Space Invaders, everybody. It took us 2 streams, but we did it. So future stream. So probably realistically, the next game stream for me is probably going to be next week. It's probably going to be Monday. It's probably going to be Hangman. And then another day next week, maybe we'll do the typing game, if not the week after that. David's on Friday doing Docker, so that'll be really cool. I'm going to try and get some more people in here. I'm going to try to get Nick in here after a couple weeks. Nick is still on vacation. But as soon as Nick gets back from vacation, you'll probably get some white hat hacking streams from him on Kali Linux and maybe some other stuff, maybe on Bitcoin and who knows what else. He's a jack of all trades. For me in the future, hopefully React. I have to learn it. It's going to take me time. It's going to be some late nights and weekends in the future before we can do that. But next week, Monday, anticipate Monday, Hangman stream. Friday, David with Docker. Tuesdays and Wednesdays are going to be a little light because we have a class in this room. But we might shift we might do a Monday, Thursday, Friday stream schedule. We may or may not still be able to do Tuesday, Wednesday, depending on how things work out. It'll at least be about 8 weeks until we resume Tuesdays and Wednesdays. React, CTF, Docker, yep, that's all stuff that I know that Nick was super interested in with the CTF stuff. It was super cool. 3 days a week sounds great, says Astley. Yeah, 3 days a week is what we'll strive for, if not more. It depends on this room's availability. This room is very popular. Sorry if you have already talked about it, but is it possible to generate an executable file? Says, I can't read that username. Caesar CXBR. An executable file. Yes, it is. So on Love2D's forum, their wiki, game distribution is the section you want to look at here on their wiki page. And it will tell you in detail how to go about creating Windows executables, for example, if you're on Windows, or a Mac OS app, for example. And also a .love file. .love is a very standard way that people making Love applications tend to distribute their games because it's pretty easy. It's just a zip archive, essentially, but it will run with the Love framework. Windows and Mac have all their instructions here for making exes. So this is how you would create, using the command line, an exe using a Love. Sorry, this is how you would use the command line to make an exe with a Love zip having been already created. It assumes that you've done that. It assumes you've created a supergame.love thing or whatever your game is .love, which is defined up here. It's part of the process. You have to do that. And then you need to, essentially, what you do is you add love.exe on top of supergame, or whatever. They say supergame.love. That's just the name of their game. Whatever your game's name is .love, you add the love exe itself, the actual love exe, so that it'll run when you double-click it on a Windows computer. And then it'll receive the name whatever exe afterwards. And I use this /b as well, which I'm not entirely sure what that is. It probably means binary appending the exe and the .love thing, the .love binary on top of it. And then you can create a batch. It has instructions for creating a batch file to do it. You can do the same. It's the exact same thing, sort of, for Linux and OS X using the cat command. So I do think that /b is just adding them on top of each other. But yeah, fairly straightforward. Creating a Mac OS X application is a little bit more complicated. The Mac OS X application is a little, yeah, they have a little bit more stuff. They have like a package with contents and some plist files and whatnot. But all the information is there on that page, so definitely check it out. 1-2 streams per week, says Bavik Knight. Yeah, I don't want to do only 1 to 2. I want to do at least 3. So we'll try and figure it out. I have to figure out the scheduling for this room, make sure that we have the time and the bandwidth for it, make sure I can get enough people to contribute, which I know Nick's on board when he gets back. David's usually on board once every week or two. I can do 1 or 2 a week, so we should have enough. We'll work on it. We'll get a schedule. Am I teaching this semester in the extension school? Yes, online only though. Online only version of the GD50 course. Andre says, any Unity streams in the near future? Probably, yeah. I would love to do some more Unity stuff. I'm a big fan of Unity, and I want to get better at it and practice doing it. So yeah, expect some Unity stuff. I'll have to brainstorm and think of some fun stuff. I really want to make a 3D platformer at some point, as I mentioned on prior streams, but that's complicated. That's like a very large project. So something smaller would be nice. I'll think about it. I have no concrete games in mind just yet. A stream to make an app would be nice with React Native, but perhaps Brian could help with that. React Native, that'd be interesting. I'll see if Brian's familiar with React Native. I've been asking him to get involved in making some more streams with us. He's doing a sort of mini workshop course on campus, so he's been a little bit bandwidth locked, but maybe after a couple weeks have passed. Any streams about functional programming in the near future, says Bavik? Nothing planned, but I would love to do something like that, because I have also been wanting to get better at functional programming. I'm a big fan of Clojure, and I've also wanted to learn Haskell, so it would be fun to do some of that on stream. Solving the Rubik's Cube in Unity, yeah, Bavik Knight, that's true. I thought about that, brainstormed that briefly actually last year after we talked about it on stream, and it would be possible, but it's going to be somewhat difficult, and I don't know exactly offhand how I would do it, so I would need to brainstorm more, I think, before actually committing to that. I don't want to spend too much time kind of umming and ahhing over on the camera. I kind of want to have a game plan before I set up so that it's not too awkward and quiet, but we'll see. I heard from a reliable source that coding your own games is easier than you think. You know, you should take this online Unity course on Udemy. Take this online Unity course on Udemy. Oh, that's the Ben Tristram reference. Yeah, because he does that. Did you finish the Udemy course? I did not finish it. I got through, I think, a few of the games, and then I got distracted with something. I have like 20 Udemy courses I have to complete, including some React ones that I just bought. So we'll see how that goes. I swear I see that in 25 times a day at least. Last year sounds so weird. Yeah, it was last year, technically speaking. It's already been, I mean, it's been almost a month since we streamed. It's been a month since we streamed Space Invaders, more than a month. The first part, it was November 26th, is when I committed. Udemy courses, plenty impending there, yes. Is that? So I use Udemy too, says Sir Demir24. I do, not a lot, to be honest. The last time I really used it was probably 2 years ago. And I've recently bought some new courses to try. Like I said, I want to get good at web dev, so I bought a couple of Udemy courses on React and modern web dev, so we'll see. And some AI and machine learning courses. That is going to be a little slower paced for me, I think, because especially if I want to understand everything really well, I think there's going to be more math behind that. We'll figure that out. But AI and machine learning are courses, topics that would be cool to have like Nick and someone else talk about more on camera, because I think those topics are really cool. Try to finish the Udemy course before Colton student surpasses the teacher. Yeah, definitely do so. I'll be very proud of you, if you do that. I honestly don't know if I'll get back into that Udemy course, because Cat-like coding is a resource that I think I would want to work through first, and it goes into more depth than the Udemy course does. The Udemy course is a little bit simpler, I think. Not that it's not very easy. It does teach you a lot, and there's a lot of good stuff in it. But Cat-like coding, I think, is like pretty next level. So if anybody's not familiar, catlikecoding.com. I'll pull it up here. Really good resource for learning Unity. Do it with tutorial section. I actually haven't checked it recently. They might have some new stuff on here. The person that does this is really, really, really crazy smart. Does a lot of really good stuff. Really goes into like the low-level side of Unity, which is not something that you see a lot. Like actually has you digging into the rendering engine and doing like custom shaders from scratch, all kinds of really cool stuff. Yeah, really cool. Cat-like Coding is a brilliant website, says Andre. I agree. Udacity, I like Udacity courses more than Udemy. Udacity offers nano degree about some AI ML courses. Interesting. I haven't looked too much into Udacity, to be honest. Coursera I have seen. I think Andrew, I don't know if it's Andrew, I don't know how to pronounce the last name, Andrew Ng, but he does an ML course, and his is very well received. And I think he's on Coursera, if I'm not mistaken. His was one that I wanted to get through, but it's a little dense, and I just haven't had time to really dig into it, or the motivation to really go all in on machine learning, but sometime soon. edX, Coursera are the best because of affiliation with a great university. Yeah, edX and Coursera are great. Speaking of that, CS50 2018 materials are on edX now as CS50X 2019, so check those out if you want to see all of the latest lectures and the latest course materials. We got that shipped over the winter break, so super cool. Can everybody else take an even vacation while I catch up on coding, says Astley. Wouldn't that be nice? An even longer vacation. The landscape is always changing, I guess. But you know, as long as you put in the effort, I think, and you're consistent about it, I don't think you need to worry about everybody surpassing you forever. I think you'd be just fine. Just go at your own pace, enjoy the process, enjoy the journey. You don't want to spend years doing something that you hate doing, right? And eventually you learn, or at least I learned, to really enjoy the journey. The destination is great, being able to build stuff, but learning stuff, if you can enjoy learning, then you'll always be on top of things, or at least relatively so. You'll always at least enjoy the process, and I think go farther than a lot of people that are less interested in it, or maybe monetarily influenced. You know, because there's so much to learn. If you don't enjoy it, then it's not going to stick as much, in my opinion. I don't enjoy everything I learn in CS, not every single thing, but I would say I can appreciate and enjoy the vast majority of it. Certain things I don't really enjoy too much. Can't think of examples offhand, but there are certain topics that are less exciting. Definitely agree on almost everything. I wanted to learn stuff like in the Matrix. Yeah, that'd be really cool. Everybody has their own time. Some start a business at 25 but die at 50, and some start life after 50 and work 40 years. Yep, very true, very true. It's all relative, like CS50 says, it's not relative to other people, it's relative to how you were when you began, right? How you are now relative to how you are at X time ago is what's important, not how good you are relative to your neighbor. Is the new CS50 stuff out? Yes, the new CS50 stuff is on edX now. That's the one thing I love the professor says. Yep, it's a great, great expression. Very true. Words of wisdom. Okay, I think we're about ready to wrap up. It's been a pleasure talking with all of you and a pleasure being back in 2019 on stream. I'm glad we were able to get everything set up and working. Everything's good. We learned and completed Space Invaders, so it's a very successful stream in my opinion. It went smoothly. There weren't too many great hiccups. Fatma says, great to see you. You rocked at the Harvard Fair. Thank you so much. Good to see you as well. Hope to see you on TV. Timing for Friday, says Bavik. David's going to be on at 3:30 Eastern Standard Time, so a little bit later. Ikimasyo, so thanks for tuning in. And that means I will go. Fun fact. I will go, exclamation point. Good to have you back, says Ashley. Thank you very much. Cool. All right, everybody. I'm going to transition to the bigger screen here. I'm going to bid all of you an awesome rest of the week until Friday, which I'll be here with David co-hosting. We'll talk about Docker. Docker's super cool, super modern. Ties in well with all of the DevOps stuff that Kareem and I have talked about before. Kareem, I'm going to try to get him on stream as well. If we could, it'd be nice. Caesar says it would be nice if you could present a minimum Super Mario game style, for example, where it seems they work with some kind of maps. Yeah, we could maybe do something like that. We do that in my games course, actually. We implement a version of Super Mario. So if you haven't checked that out, go to cs50.gg actually should now point to the games course, although it's old content. Yeah, this is the games course for 2019. We table contents, Super Mario Brothers. Is it still here? No, it's not. The URLs are the URLs are all what's it? Sort of temporary before we actually get the class fleshed out. But if you go to the CS50's YouTube channel, our game development playlist, and type in Super Mario Brothers, I show how to implement a sort of basic Super Mario Brothers style game. And we could maybe certainly take a look at doing something like that again in the future. It's a nice, fun demo. Cool. All right, everybody. Thanks so much for tuning in. See you all on Friday. Enjoy the rest of your week. This is CS50 on Twitch, and I'll see you all next time. Bye-bye.